Tonight, we're going somewhere the sun has never been. A few hundred meters below the surface of the ocean, light disappears, not dimmed, not softened, gone. And below that line, stretching down for miles, is a world that has never known color, never known warmth, never known the rhythms that shape life on land. More than 70% of our planet is covered by the ocean, yet humans have explored less than 5% of it. We think of Earth as a world of forests and grasslands, of animals that breathe air and walk in sunlight. But the majority of life on Earth exists in darkness, drifting, glowing faintly, shaped by pressures and silences we can barely imagine. Down here, the rules are different. Bodies take forms that would seem impossible on the surface, eyes that have never seen light, skin that has never felt warmth. Creatures so delicate they would fall apart in our hands, yet so resilient they thrive in conditions that would crush anything built for the world above. Scientists who study these depths often describe the same quiet surprise. The deeper you go, the less life looks like anything we recognize. And yet it is life, patient, ancient, perfectly adapted to a world we are only beginning to understand. But why does life change so completely as it sinks deeper into the ocean? What happens to biology when light, warmth, and pressure all cross invisible thresholds? And what kind of environment reshapes life into forms that feel almost unreal? Tonight, we'll sink gently into that darkness. We'll meet the creatures who live beyond the reach of the sun. But before we begin, if you enjoy slow, soothing explorations like this one, calming journeys through the wonders of science, I'd be grateful if you gave this video a like and perhaps tapped subscribe. And if you'd be so kind, let me know in the comments, where are you winding down from tonight, and what time is it there? It's always a joy to see how far across the world this little sleepy corner of science travels. Now, let your breath slow, let your body settle, and together let us drift gently into the alien calm of the deep ocean. As we continue our descent, the ocean begins to reveal a quiet order beneath its vastness. What first appeared as a single endless body of water slowly separates into layers, each one shaped by depth, distance from the surface, and time itself. The ocean is not uniform, it is structured, tiered, and divided, not by walls or borders, but by gradual shifts in light, pressure, temperature, and energy. Near the surface, movement dominates. Waves roll overhead, stirred by wind and weather. Sunlight pours down freely, scattering into ripples that dance across the water. Heat is absorbed here, warming the upper layers and keeping them in constant motion. This mixing creates a restless environment, one that changes from hour to hour, season to season. Life here is built for variability, for motion, for the rhythm of days and nights that pulse through the water like a heartbeat. But as depth increases, those surface forces begin to fade. The water grows calmer. Temperature drops, slowly at first, then more decisively. Light weakens, thinning into narrower bands that reach only so far before surrendering to shadow. These changes do not happen randomly. They follow patterns shaped by physics, by how sunlight travels, by how water holds heat, by how gravity presses downward. Each step deeper brings a predictable shift, as though the ocean is quietly reorganizing itself layer by layer. Pressure increases steadily, compressing everything beneath it. Water above adds weight without mercy, but also without surprise. This pressure rises at a constant pace, creating environments that repeat in structure even as they differ in detail. Because of this consistency, life does not encounter chaos as it descends. It encounters thresholds, points where familiar strategies stop working and new ones begin to take their place. These thresholds divide the ocean into zones, each one marked by a balance of conditions, that remain relatively stable within their depth range. Light fades to darkness, warmth gives way to cold, energy becomes scarce. Each layer settles into its own quiet equilibrium, separated from the ones above and below, not by sharp edges, but by slow transitions that nonetheless shape life in powerful ways. What makes these layers feel like separate worlds is not just how different they are, but how little they interact. Water does not mix freely between all depths. Temperature differences create barriers. Density holds layers apart. Nutrients sink slowly. Light never returns once it is lost. As a result, organisms adapted to one layer rarely cross into another. A creature born into one depth zone experiences an environment so distinct that moving up or down, even a short distance, can feel like stepping onto a different planet. In one layer, food rains gently from above, fragments of life drifting down from brighter waters. In another, almost nothing falls, and survival depends on patience and efficiency. Some layers are shaped by motion, others by stillness. Some experience seasonal change, others remain nearly constant for centuries. Time itself seems to move differently as depth increases, marked less by cycles and more by continuity. Because these conditions remain so stable, evolution responds with precision. Bodies adapt not to the ocean as a whole, but to specific layers within it. Muscles, senses, and shapes are tuned to the exact balance of pressure and energy available at that depth. Even small changes in environment can make survival impossible, which is why these layers feel isolated despite sharing the same water. From above, the ocean appears continuous and unified. From within, it is fragmented into stacked habitats, each one governed by its own rules. These rules are not written, but enforced by physics, repeated endlessly, quietly shaping life over immense spans of time. As we drift deeper, the sense of moving through a single place begins to dissolve. Instead, we pass through environments that feel self contained, each one complete in its strangeness. The ocean becomes less like a single world and more like a vertical universe, layered, patient, and profoundly ordered, waiting for us to notice how different each depth truly is. As we continue downward, the ocean does not suddenly darken, it changes more gently than that. Light does not vanish all at once. It thins, stretches, and weakens, filtered slowly by the water itself. What remains is no longer the full presence of sunlight, but a softened version, reshaped by distance and depth. Water is not empty. Every drop bends, scatters, and absorbs light as it passes through. Tiny particles drift in suspension, plankton, minerals, fragments of organic matter. Each one interrupts the path of light, stealing small portions of it away. With every meter, brightness fades, not because the sun grows weaker, but because the ocean quietly takes what it can no longer carry. Color is the first thing to change. Sunlight contains many wavelengths, each traveling differently through water. The longest wavelengths struggle the most. Reds disappear first, absorbed within the upper layers, leaving blood dark and shadowed, turning familiar signals invisible. What once flashed bright becomes muted, then gone. Orange follows soon after, then yellow, each color slipping away as depth increases. What remains is a narrowing palette, dominated by blue and faint green, the colors best suited to travel farther through water. This loss happens gradually, but its effects are profound. The world does not simply become darker, it becomes simpler. Objects lose contrast, surfaces blend into one another, edges soften. Without color, shape, and motion become the primary cues for survival. A creature that once relied on bright markings or visual warnings finds those signals erased by the water long before darkness fully arrives. For life, this change reshapes everything. In the upper layers, Color can mean attraction or warning, camouflage or display, but as those colors fade, their usefulness fades with them. Maintaining pigments becomes costly when they no longer serve a purpose. Over time, many organisms abandon color entirely, their bodies growing pale, silvery, or translucent, better suited to reflect the faint light that remains. Others adapt in subtler ways. Patterns shift from bold contrasts to delicate textures. Reflective surfaces scatter what little light exists, making bodies harder to outline. Some creatures turn darkness into advantage, using shadow rather than color to disappear. The ocean rewards whatever reduces visibility, whatever helps a body blend into the blue dimness around it. As color drains away, vision itself becomes unreliable. Eyes tuned for brightness struggle in the growing gloom. Seeing far becomes difficult. Seeing clearly becomes rare. In this environment, evolution begins to favor sensitivity over sharpness. Larger eyes gather more light, even if that light carries less information. In some species, eyes stretch and widen, becoming soft windows designed to catch every passing photon. In others, eyes begin to shrink. When light offers too little to justify the energy required to see, vision becomes an unnecessary expense. Over generations, eyes fade, then disappear, replaced by other ways of sensing the world. Touch, vibration, and chemical signals take on greater importance, offering information that light no longer provides. The loss of color also changes how creatures find one another. Signals based on appearance become less reliable, pushing communication toward movement, timing, and eventually light produced from within. But here, the absence of color still shapes behavior long before any glow appears. Survival depends on conserving energy, on avoiding detection, on reading the faintest cues left behind by a world where sunlight can no longer reach. Even time feels different here. Without strong light, daily rhythms weaken. Shadows no longer mark the passing hours. Life drifts into slower patterns, guided less by cycles and more by scarcity and opportunity. The sun still exists far above, but its influence has thinned into something indirect, almost forgotten. This is not yet darkness, not the complete black that waits farther below. It is a place of fading, where sunlight still arrives, but altered, diminished, stripped of its colors and certainty. A world where life learns to let go of what once worked and begins the long, quiet adjustment to seeing less and sensing more as the ocean gently closes the distance between light and shadow. As the descent continues, a quiet boundary is crossed. It is not marked by darkness alone, nor by pressure or cold, but by absence. This is the depth where photosynthesis no longer functions, where light has weakened beyond usefulness, and where one of Earth's most familiar processes gently comes to a stop. Photosynthesis depends on a narrow window of conditions. It requires light strong enough to drive chemical change, water clear enough to let that light pass, and time spent close to the surface where energy arrives daily. In shallow waters, this balance holds. Microscopic algae drift near the sunlit ceiling of the sea. Sea grasses root themselves where light still reaches the seafloor. Energy flows downward from the sun into living tissue, stored patiently in cells. But as depth increases, light thins beyond recovery. Even before darkness becomes complete, sunlight loses the strength required to power this transformation. The remaining glow may still be visible, but it is no longer usable. It cannot split molecules. It cannot sustain growth. What remains is illumination without nourishment. Below this threshold, plants do not slowly fade away. They simply cannot exist. There is no adaptation that allows photosynthesis to function without sufficient light. No shape, no pigment, no strategy can overcome that limitation. And so, at a certain depth, The ocean becomes a place without producers, without organisms capable of turning sunlight into food. This absence reshapes everything that follows. On land and in surface waters, food chains begin with plants. They form the base that supports every grazer, every predator, every complex ecosystem. Remove that base, and the familiar structure collapses. Below the reach of photosynthesis, the ocean no longer produces its own energy. Instead, it waits. Food arrives from above, drifting downward in slow motion. Tiny fragments of dead plankton, discarded shells, waste, and organic debris sink gently through the water column. This steady fall is sometimes called marine snow. Though it does not sparkle or vanish, it accumulates slowly, unevenly, carrying the remains of surface life into the deep. For creatures below, this falling material becomes the primary source of nourishment. It is unreliable, unpredictable, and scarce. Some days bring abundance, others bring nothing at all. Survival here depends not on speed or competition, but on patience. Bodies adapt to store energy, to consume infrequently, to make use of whatever arrives. As depth increases further, even this rain thins. The distance from the surface grows too great. Much of the material is consumed long before it reaches the deepest layers. What remains is sparse, scattered, and often poor in energy. Life responds by slowing down. Growth becomes deliberate. Movement becomes measured. Waste is minimized. Nothing is taken for granted. In some places, a different source of energy appears, not from above, but from within the earth itself. Along cracks in the seafloor, warm fluids seep upward, rich with chemicals released from the planet's interior. Here, bacteria form the foundation of a new kind of ecosystem. They do not rely on light. Instead, they draw energy from chemical reactions, converting substances like sulfur compounds into usable fuel. These microbial communities support entire networks of life. Larger organisms gather around them, feeding directly or indirectly on this chemical production. It is a quiet proof that sunlight, while powerful, is not the only path to life. Energy can come from gradients, from imbalance, from the slow chemistry of a restless planet. Yet even these systems are limited, isolated, and rare. For most of the deep ocean, energy remains scarce, borrowed from the surface or gathered from remnants. There is no endless supply, no steady renewal. Every calorie matters. This is the world beyond photosynthesis, a place where life no longer begins with growth, but with endurance, where ecosystems are built not on abundance, but on efficiency, where the absence of light reshapes the flow of energy itself, forcing biology to become quieter, slower, and remarkably precise. As we drift onward, the ocean continues to narrow the options available to life. With each layer, something familiar is left behind, replaced by strategies that suit a world where the sun's influence has finally, gently, come to an end. As depth increases, the ocean becomes a place where vision no longer offers certainty. Shapes blur, distances collapse. What little light remains is scattered and unreliable, arriving from odd angles or fading without warning. In this environment, sight stops being a dependable guide. It still exists for some, but it no longer rules behavior the way it does near the surface. Vision is demanding. Eyes require constant energy, steady maintenance, and complex processing. Muscles must move them. Nerves must interpret their signals. Brains must devote space and power to making sense of what they receive. All of this is worthwhile in a bright world, where seeing means finding food, avoiding danger, and recognizing others. But as light weakens, the cost of vision remains high while its rewards quietly shrink. In the deep ocean, energy is scarce and precious. Every unnecessary expense becomes a liability. Over time, natural selection begins to favor restraint. Eyes that once offered advantage now drain resources without providing enough return. For some creatures, vision narrows, becoming more sensitive but less detailed. For others, it fades into something secondary, no longer trusted as the primary sense. This shift does not happen abruptly. It unfolds slowly, over generations, as small changes accumulate. Eyes may remain, but their role changes. They become tools for detecting movement rather than form, glow rather than color, presence rather than detail. Seeing becomes less about understanding the world and more about noticing that something is there at all. As vision retreats, other senses step forward. Water is an excellent carrier of information. Vibrations travel through it far more efficiently than through air. A subtle movement can ripple outward, announcing presence long before contact. Many deep sea creatures become exquisitely sensitive to these disturbances. Their bodies detect pressure changes, shifts in flow, and faint tremors that reveal motion in the dark. To them, the ocean is never silent. It hums softly with signals. Chemical cues also grow in importance. Scents linger longer underwater, spreading slowly and persistently. Traces of food, mates, or danger drift through the water like invisible threads. Organisms learn to follow these trails with precision, reading the chemical landscape as clearly as surface animals read sight. What humans would call smell becomes a form of navigation, communication, and memory. Touch, too, evolves beyond simple contact. Fine hairs, extended fins, and sensitive skin allow bodies to feel the world around them without needing to see it. Some creatures sense objects before touching them, detecting subtle changes in water movement that outline shapes in the darkness. The environment is mapped not by light, but by pressure and flow. As these senses grow more important, behavior changes with them. Movements become slower and more deliberate, not from weakness, but from strategy. Sudden motion creates noise in the water, vibrations that can travel far. In a world where detection can come from any direction, restraint becomes a form of camouflage. Communication follows the same path. Visual displays lose their value. Bright colors and gestures no longer carry meaning. Instead, timing, proximity, and chemical signals take their place. Some species release specific compounds into the water, messages that persist long after the sender has moved on. Others rely on rhythm, repeating movements or pulses that can be felt rather than seen. Brains adapt alongside bodies. Neural resources shift away from visual processing and toward integrating other streams of information. The mind becomes less focused on images and more attuned to patterns of change, subtle cues that unfold over time. Awareness stretches outward in new ways, no longer centered on what is visible, but on what is detectable. In this world, blindness is not a loss, it is an adjustment, a response to conditions where sight no longer offers safety or advantage. What replaces it is not confusion, but clarity of a different kind. Life learns to listen to the water, to feel it, to read its slow signals with patience and precision. As we drift deeper still, the ocean continues to reshape perception itself. The familiar hierarchy of senses dissolves. Vision steps back. Touch, vibration, and chemistry take the lead. Life does not become diminished without sight. It becomes differently aware, tuned to a world where information arrives quietly, steadily, and from every direction at once. As we move deeper, another force takes quiet control. It is never seen, never heard, yet it presses on everything equally and without pause. Pressure surrounds the body from all sides, steady and immense, shaping life not through sudden violence, but through constant insistence. Water is heavy. Each layer above adds its weight, and with depth, that weight becomes overwhelming. For life in the deep, pressure is not an occasional challenge. It is the background condition of existence, present in every movement, every pause, every breathless moment. Over time, this invisible force begins to sculpt biology at the smallest scales. Inside living cells, pressure changes how molecules behave. Proteins, which fold into precise shapes to do their work, become sensitive to compression. Under high pressure, these shapes can twist or loosen, altering how reactions unfold. Membranes, the thin boundaries that hold cells together, face constant stress. They must remain flexible enough to bend without breaking, yet stable enough to protect what lies within. To survive, deep-dwelling organisms adjust their chemistry. Their membranes contain different blends of fats, ones that remain fluid instead of stiffening under compression. Their proteins are built to function while squeezed, maintaining their structure even as pressure tries to flatten them. These changes are subtle, invisible from the outside, yet essential. Without them, life would simply stop at the molecular level. Pressure also reshapes the larger architecture of bodies. On the surface, rigid structures offer strength and protection. Bones provide leverage. Hard shells resist attack. Stiffness allows powerful movement against gravity. But in the deep ocean, these advantages reverse. Pressure does not push from one direction. It presses evenly from every side, finding weaknesses in rigid forms. Hard shells become liabilities. Under intense pressure, any trapped air or hollow space becomes dangerous. Even solid structures face stress at joints and seams, places where cracks can form. Rigid bones resist bending, but that resistance concentrates force instead of dispersing it. Over time, stiffness increases the risk of damage rather than preventing it. As a result, many deep-sea creatures grow softer. Skeletons become lighter or partially reduced. Cartilage replaces bone. Muscles relax into slower, gentler arrangements. Bodies that yield slightly under pressure fare better than those that fight it. Flexibility allows force to pass through without causing harm. This softness is not weakness, it is efficiency. A flexible body requires less energy to maintain and less repair when stressed. It moves with the water rather than against it. In a world where energy is limited and pressure is constant, this approach offers quiet advantage. The biological cost of stiffness extends beyond structure. Maintaining rigid tissues demands resources. Dense bones and thick shells require minerals and continuous upkeep. Muscles built for power consume energy even at rest. In the deep ocean, where food arrives slowly and unpredictably, these costs accumulate. Evolution favors bodies that do more with less, conserving energy wherever possible. Even movement reflects this shift. Instead of strong, rapid motions, many deep-sea animals glide, drift, or pulse gently. They rely on buoyancy rather than force, adjusting their density to hover effortlessly. Pressure supports them as much as it constrains them, allowing motion without strain. Over generations, pressure becomes a guiding hand. It filters out forms that resist too strongly and preserves those that adapt quietly. Life does not conquer this environment by standing firm, but by yielding in precise ways. Cells soften, tissues relax, structures simplify. What emerges is a biology shaped by endurance rather than resistance. Every cell, every protein, every membrane carries the imprint of pressure, not as damage, but as design. The deep ocean does not punish life for being fragile. It rewards forms that understand how to bend, how to flow, how to exist within a constant, crushing embrace. As we continue our descent, pressure remains ever present, invisible and unchanging. It does not announce itself. It simply continues to sculpt, slowly and patiently, guiding life toward forms that reflect the quiet truth of the deep. Strength here is not found in hardness, but in the calm resilience of bodies that have learned how to live while being endlessly pressed. As pressure continues to shape life from the inside out, its influence begins to appear more clearly on the surface. Forms change, outlines soften, bodies lose the firm edges and solid frames that feel familiar in the world above. In their place emerge shapes that seem fluid, delicate, and unfinished, as if still forming. Yet these bodies are not incomplete. They are precisely tuned to the deep. Gelatinous tissues become increasingly common as depth increases. These tissues contain large amounts of water held within flexible networks of protein and cells. Instead of resisting pressure, they share it. Force moves through them evenly without concentrating stress in one place. Where rigid structures might crack or collapse, gelatinous bodies simply yield, maintaining their integrity by allowing pressure to pass harmlessly through. This softness provides quiet advantages. Gelatinous tissues are lightweight and require little energy to maintain. They reduce the need for heavy skeletons and dense muscles, both of which are costly in an environment where food is scarce. By matching the density of the surrounding water, these bodies achieve near neutral buoyancy, hovering effortlessly without constant movement. Gravity loses its grip, and motion becomes slow, controlled, and economical. In the deep ocean, strength is not measured by force or speed. It is measured by persistence. A soft body can endure pressure without fatigue. It can drift for long periods without expending energy. It can survive on infrequent meals. These qualities matter more than power in a world where resources arrive unpredictably and competition is subtle rather than violent. Yet this same softness creates a striking contrast when deep sea creatures are removed from their environment. Outside the pressure that shaped them, their bodies often fail, tissues collapse, shapes distort. What once functioned perfectly becomes fragile in unfamiliar conditions. This fragility can be misleading. It suggests weakness where none exists. In truth, these bodies are strong only within the precise balance of pressure and buoyancy they evolved to inhabit. This dependence reveals the deep trade-off between strength and survival. Rigid bodies are versatile. They can move between environments, withstand impacts, and support complex motion. But they come with high costs. They demand energy, resources, and constant maintenance. In the deep ocean, these costs outweigh the benefits. Survival favors forms that do less, but do it well. As rigidity fades, bodies become stranger to human eyes. Symmetry loosens, shapes stretch or compress. Some creatures resemble drifting veils, others long ribbons or translucent bells. Organs shift position, muscles thin. What remains is enough structure to function, and no more. Efficiency replaces familiarity. These forms are not accidents. They are the result of long refinement under stable, extreme conditions. Over time, evolution trims away excess, Anything that does not directly contribute to survival is reduced or lost. Decorative features vanish, heavy armor disappears. What remains is quiet utility, expressed through softness and flexibility. This softness also changes how these creatures interact with their surroundings. Movement becomes subtle. Instead of sudden bursts, bodies pulse gently or glide with slow waves of motion. These movements disturb the water less, conserving energy and avoiding detection. In a place where every vibration carries information, restraint becomes a form of safety. Even feeding reflects this shift. Soft bodies can expand and contract, accommodating meals larger than their resting size. Elastic tissues stretch without tearing, allowing rare opportunities to be fully exploited. When food is unpredictable, the ability to adapt physically in the moment can mean the difference between survival and starvation. To human observers, these creatures often appear unfinished or unreal. Their softness defies expectations shaped by life on land. But in the deep ocean, this softness represents completion. It is the final form reached after countless generations of adjustment, guided by pressure, scarcity, and time. As we drift alongside these shapes, the ocean feels less solid, less defined. Life blends into water, boundaries soften, and forms become suggestions rather than declarations. Strength here is quiet and precise, found not in resistance, but in the ability to exist comfortably within conditions that never change. Bodies become softer because softness works. They become stranger because the deep rewards honesty over familiarity and survival over shape. The descent brings us into a region that still remembers the sun, but only faintly. Light is present here, yet altered beyond comfort. It arrives thin and angled, filtered through so much water that it no longer behaves the way surface life expects. Shadows exist, but they are soft and unreliable. Brightness no longer comes from above alone. It seems to drift, scattered and uncertain, as if the ocean itself is holding on to the last traces of day. This is the twilight zone, a boundary layer where sunlight makes its final appearance before surrendering completely. The glow that remains is dim and blue, stretched thin by distance. It is not enough to warm, not enough to nourish, but enough to reveal movement. Shapes can still be seen, though not clearly. Forms appear and vanish at the edge of perception, never fully defined, never entirely gone. Life here begins to change in visible ways. Bodies that once followed familiar outlines start to loosen their rules. Fish grow longer, slimmer, their profiles stretched as if pulled gently by the dark below. Fins widen or narrow, heads tilt upward, mouths shift position. These are not extreme transformations, not yet. They are adjustments, subtle but persistent, signaling that the old designs are beginning to fail. Color, already fading, becomes even less reliable. Pigments lose their purpose. Many creatures adopt silvery skins that reflect the faint light around them, dissolving their edges into the surrounding water. Others darken, absorbing what little illumination remains. Camouflage here is not about blending into coral or plants, but about blending into absence itself. Eyes tell a similar story. In the twilight zone, vision still matters, but it must stretch to its limits. Some species develop larger eyes, rounded and sensitive, built to gather every remaining photon. These eyes do not offer clarity, they offer awareness. They detect motion, contrast, and presence rather than detail. Seeing becomes a way of sensing that something is nearby, not understanding exactly what it is. At the same time, other senses continue to grow in importance. The water carries vibrations and chemical traces more reliably than light ever could. Vision begins to share its role, no longer dominant, no longer trusted alone. This blending of senses creates a way of perceiving the world that feels unfamiliar to surface life, yet not entirely strange. The twilight zone feels unsettling because it sits between worlds. It is not bright enough to feel safe, and not dark enough to feel hidden. It holds reminders of the surface without offering its comforts. Familiar shapes linger, but altered. Movement resembles what we know, but behaves differently. Nothing here is truly alien, yet nothing feels entirely right. This unease comes from recognition without reassurance. The brain tries to apply surface rules to what it sees, and they no longer fit. A fish shape passes by, but it moves too slowly. An eye reflects light, but the body around it seems incomplete. Proportions shift, expectations quietly fail. Life in this zone often lives with tension. Predators and prey can still see one another, but not well. Encounters unfold at the edge of visibility. Timing becomes critical. Many species adopt daily migrations, rising toward the surface under cover of darkness and sinking back into the twilight during the day. This constant movement links the worlds above and below, carrying energy downward and returning nutrients upward, a slow breathing of the ocean itself. Because of this movement, the twilight zone is never still. It is filled with passing life, drifting bodies, brief encounters. Yet despite this activity, it remains dim and quiet, suspended between illumination and darkness. It feels transitional, as though everything here is in the process of becoming something else. This is why the zone unsettles rather than astonishes. It does not confront us with forms too strange to comprehend. Instead, it offers familiarity that has begun to unravel. It shows life halfway through its transformation, no longer suited to the surface, not yet fully shaped by the deep. As we drift through this dim layer, the ocean seems to hesitate. Light lingers for a moment longer, stretched thin but present. Shapes continue to echo what we know, even as they slowly let go. And in this soft fading, the sea prepares life for what comes next, guiding it gently toward a world where familiarity will finally disappear and new rules will quietly take over. As the ocean grows darker, vision reaches a turning point. In the fading light of the deeper layers, eyes are no longer simply useful features. They become choices, costly ones, shaped by the quiet arithmetic of survival. Some species invest heavily in sight, allowing their eyes to grow large and sensitive. Others take the opposite path, letting vision fade away entirely. Both strategies arise from the same environment, guided by the same pressures, and both make sense when energy becomes the rarest resource of all. In the deep, light is not absent everywhere. It appears briefly, faintly, and unpredictably. A distant silhouette may pass overhead. A glimmer may reflect from scales. A brief flash of living light may flicker in the dark. For species that rely on these fleeting moments, larger eyes offer advantage. Bigger eyes collect more light, much like wider windows gather more moonlight at night. Even a small increase in size can make the difference between detecting movement and drifting past it unnoticed. These enlarged eyes are not built for detail. They do not see color clearly. They do not resolve sharp edges. Instead, they act as light collectors, tuned to contrast and motion. They are often soft and rounded, filling much of the head, sometimes dominating it entirely. In some species, the eyes appear oversized compared to the body, an adaptation that looks strange to human observers but serves a precise purpose. This investment comes at a cost. Eyes require energy to build and maintain. The tissue must remain functional. Nerves must transmit signals. The brain must process incoming information. In an environment where food is limited and unpredictable, this is a significant expense. Species that evolve large eyes do so because the benefit outweighs the cost. For them, spotting prey, predators, or mates even once can justify the energy spent. Other species face a different calculation. In regions where light is too rare or too weak to offer reliable information, vision becomes inefficient. An eye that rarely receives useful input still consumes resources. It still demands maintenance. Over time, natural selection favors reduction. Eyes shrink, structures simplify. In some cases, they disappear entirely. The loss of eyes is not sudden. It unfolds gradually across generations. Vision becomes less central to survival, replaced by other senses better suited to the environment. As eyes lose their importance, mutations that reduce their size or function are no longer harmful. They may even be beneficial, freeing energy for other uses. Eventually, what remains is a body without visual organs, navigating the world through touch, vibration, and chemical signals alone. This absence does not mean blindness in the human sense. It means a different way of knowing. For these species, sight offers no advantage, and so it is gently set aside. The brain reallocates resources. Neural space, once devoted to vision, supports other sensory pathways. Awareness does not diminish, it shifts. The decision between growing eyes or losing them is shaped by energy math. Every organism operates within a budget. Energy taken in must support movement, growth, repair, and reproduction. In the deep ocean, income is low and unpredictable. Waste is costly. Any trait that does not provide consistent return becomes a burden. Large eyes pay off only if light appears often enough to matter. If bioluminescent flashes are common, if silhouettes pass overhead, if detecting motion improves survival even occasionally. In these cases, investing in vision makes sense. But where darkness is near total and encounters are rare, the return falls below the cost. In those places, blindness becomes efficiency. These two strategies can exist side by side, even within the same depth range. One species may rely on rare flashes of light, while another ignores light altogether. Both succeed because they align their biology with the conditions they face most often. There is no single correct solution, only balance. To human eyes, this divergence feels dramatic. Massive eyes staring out from the dark, or smooth faces where eyes should be, seem extreme. Yet both outcomes are quiet answers to the same question. How much energy is vision worth in a world that barely offers light? As we drift deeper, these choices become more pronounced. Eyes either grow toward the darkness, stretching to gather what little remains, or they retreat entirely, leaving the task of awareness to other senses. In both cases, life adapts not out of preference, but out of necessity, shaped by careful trade-offs made over immense spans of time. Here, sight is no longer assumed, it is negotiated. And in that negotiation, the deep ocean reveals how flexible biology can be when survival depends not on seeing more, but on spending wisely. As natural light thins into near absence, something unexpected begins to appear. In the deep ocean, light returns, not from above, but from life itself. Small glimmers punctuate the darkness. Brief flashes bloom and vanish, soft glows drift past like distant stars. This is not sunlight lingering, it is light recreated, shaped by biology to serve new purposes in a world where the sun no longer reaches. Bioluminescence emerges as a response to scarcity. When vision still matters, but light no longer arrives reliably, producing light becomes a way to regain control. For many deep sea creatures, generating their own illumination is more efficient than relying on what little remains from the surface. The chemistry behind this glow unfolds quietly inside cells, where specific molecules release light without heat. A cold fire perfectly suited to the surrounding water. This light is not constant. It is used with care. Energy is precious, and glowing without reason would waste it. Instead, bioluminescence appears in brief signals, controlled flashes, and measured pulses. Some creatures emit light only when disturbed, others glow rhythmically, their bodies tracing faint patterns through the dark. Each use carries intent, shaped by survival rather than display. For hunters, light becomes a tool. A small glow can act as a lure, drawing curious prey closer in a place where movement is rare and encounters are unpredictable. The glow may resemble drifting food or a harmless shimmer. When prey approaches, the distance closes quietly. In this way, light replaces speed, patience replacing pursuit. Other species use light to hide. Counter-illumination allows bodies to match the faint glow filtering down from above, erasing their silhouettes when seen from below. By shining light downward, they cancel their own shadows, becoming nearly invisible against the dim ceiling of the ocean. It is a delicate balance, a quiet form of camouflage that works only because light has become so scarce. Communication also finds a new language in glow. In the absence of color and clear shapes, light offers a way to signal identity and presence. Patterns of flashes differ between species. Timing matters. Duration matters. Some signals last only a moment, others stretch into slow pulses. These glowing messages allow individuals to recognize one another, to coordinate movement, or to signal readiness without revealing too much to unintended observers. Unlike surface displays, these signals are rarely ornamental. They are stripped of excess, designed for clarity in darkness rather than beauty in light. Every flash carries information, every pause matters. The deep ocean does not reward wasteful expression. To human eyes, bioluminescence often looks unnatural. The colors appear electric, sharp against the blackness. Blues and greens dominate, hues that travel farthest through water. The light seems detached from a visible source, emerging from mouths, bellies, or drifting appendages. It feels less like illumination and more like something alive in its own right. This reaction comes from unfamiliar context. On land, light usually signals heat, fire, or technology. In the deep ocean, light is quiet and cold. It does not warm, it does not spread far. It exists only where it is made, surrounded by darkness on all sides. Without reference points, the glow feels suspended, as if disconnected from physical form. Bioluminescent light also behaves differently from sunlight. It does not reveal the full shape of an object. It outlines fragments. It highlights edges. It leaves much unseen. This partial illumination confuses expectations, making bodies appear incomplete or distorted. What is revealed feels intentional, while what remains hidden invites imagination. For the creatures themselves, this light is neither strange nor decorative. It is practical. It solves problems created by depth. It allows interaction in a place where silence and darkness dominate. Over time, species refine how they glow, adjusting brightness, color, and placement to suit their needs. Some lights sit near the eyes, others trail behind. Some flicker rapidly, others hold steady. As we drift among these faint lights, the deep ocean no longer feels entirely dark. It becomes a scattered constellation of living signals, each one brief, purposeful, and carefully used. Light has not vanished here, it has been reinvented. This recreation of light marks another step in life's adjustment to depth. Where sunlight once guided behavior, biology now takes its place. Illumination becomes internal, controlled, and rare. The glow does not restore familiarity. It replaces it with something quieter and more precise, a reminder that even in the deepest darkness, life finds ways to shape its own environment, gently and without excess, using light only when it truly matters. As light becomes rare and shadows lose their meaning, another strategy quietly spreads through the deep. Instead of hiding behind armor or dark pigments, many creatures choose a different path. They become difficult to see at all. Transparency emerges not as an oddity, but as an elegant response to a world where being noticed can be costly. In brighter waters, survival often depends on contrast. Patterns break up outlines, colors warn or deceive. Hard shells and spines provide protection when contact is unavoidable. But in the deep ocean, encounters are infrequent and energy is limited. Defense through strength becomes expensive. Avoidance becomes more efficient. If a body cannot be seen, it does not need to fight. Transparent bodies work by removing visual cues altogether. Light passes through tissues instead of reflecting off them. Organs are rearranged or minimized. Pigments fade. What remains is a form that blends not with background color, but with the water itself. Against the dim glow filtering down from above, or the faint light produced by living organisms, these bodies cast little to no silhouette. Silhouettes matter in the deep. When light is scarce, shape becomes more important than detail. Predators often detect prey as outlines against a slightly brighter background. A solid body interrupts light, revealing its presence even without color. Transparency softens this interruption. Edges blur, forms dissolve into the surrounding water. A creature may be close, yet remain unnoticed. This strategy works especially well in midwater environments, where there are no rocks, plants, or surfaces to hide against. There is only open space. In such places, armor offers little advantage. A hard shell still creates a visible shape. Transparency, by contrast, removes the shape itself. Achieving this invisibility requires precise biological adjustments. Cells must be arranged to minimize scattering. Internal structures shrink or become aligned to reduce visual disruption. Even blood changes, losing strong pigments that would otherwise reveal movement. These modifications are subtle and cumulative, refined across generations until the body becomes a quiet suggestion rather than a solid presence. Yet transparency is not without cost. Armor protects against physical contact, spines deter attack, thick shells absorb damage. Transparent bodies lack these defenses. If detected and captured, escape options are limited. Survival depends almost entirely on remaining unseen. This creates a delicate balance. The strategy succeeds only as long as invisibility holds. There is also a cost to communication. Without visible markings or colors, individuals cannot rely on appearance to signal identity. Species recognition becomes more complex. Interaction shifts toward timing, movement, chemical cues, or light produced briefly and carefully. Visual identity fades, replaced by subtler forms of recognition. Even growth is constrained. Large, dense organs are difficult to hide. Transparency favors small sizes, thin tissues, and simplified anatomy. Complex structures must justify their visibility. Anything unnecessary risks revealing the body's presence. Over time, evolution trims excess, favoring forms that remain light, sparse, and difficult to outline. To human eyes, these creatures often seem unreal. Their bodies appear ghost-like, incomplete, as though parts are missing. We expect animals to have clear edges, solid mass, visible features. Transparency challenges those expectations. It feels like an absence rather than an adaptation. But in the deep ocean, transparency is a form of honesty. It reflects the reality of an environment where energy is scarce, encounters are rare, and being noticed can be fatal. Instead of building defenses that require constant investment, these organisms choose restraint. They become quieter versions of themselves, existing without announcing their presence. Transparency also works in harmony with other deep-sea strategies. Soft tissues allow light to pass through without distortion. Slow movement avoids creating disturbances. Reduced pigmentation lowers metabolic cost. Together, these traits form a cohesive approach to survival, one that prioritizes efficiency over strength. As we drift alongside these nearly invisible forms, the ocean feels emptier than it truly is. Life surrounds us, yet much of it escapes notice. Presence becomes difficult to confirm, absence becomes deceptive. In this environment, having no visual identity is not a loss, it is a solution. A way of existing without demand, without display, without confrontation. Transparency allows life to remain part of the ocean rather than standing apart from it, dissolving boundaries between body and water. The deep does not reward those who announce themselves. It favors those who pass quietly through its layers, leaving little trace, and so many creatures choose to vanish in plain sight, proving that sometimes the most effective camouflage is not color or armor, but the gentle art of becoming nearly invisible. As depth increases, the ocean begins to move at a different pace. Motion softens, urgency fades, life settles into a rhythm that feels stretched, as though time itself has loosened its grip. This change is not dramatic or sudden, it unfolds gradually, shaped by the quiet realities of energy and scarcity. In the deep ocean, movement is expensive. Every motion pushes against dense water, requiring effort and fuel. Unlike the surface, where sunlight drives abundant food webs and constant renewal, the deep offers little surplus. Meals arrive slowly, sometimes after long waiting. Energy must be guarded carefully, spent only when it truly matters. As a result, bodies adapt not for speed, but for efficiency. Muscles become lighter and less bulky. Fast twitch power gives way to slow, steady contraction. Instead of rapid bursts, movement becomes measured and deliberate. A gentle pulse of fins, a slow glide forward, a drifting pause that lasts longer than motion itself. This slow pace reshapes behavior from the inside out. Predators do not chase endlessly. There is no room for wasted effort. Instead, they wait, they hover, they let the ocean carry information to them. When action comes, it is brief and precise, guided by timing rather than force. Prey species respond in kind. Speed is no longer the primary defense. Sudden escape would require energy they cannot afford to lose. Instead, survival depends on stillness, camouflage, and awareness. Remaining unnoticed becomes more effective than outrunning danger. Silence replaces flight. Low energy availability touches every aspect of life. Growth slows, repair takes time, reproduction becomes infrequent and deliberate. Nothing happens quickly without consequence. The deep ocean favors strategies that stretch limited resources across long spans of time, rewarding patience over urgency. This slowness is not weakness, it is adaptation. In an environment where food arrives unpredictably, conserving energy becomes the highest priority. Movement is reduced not because life is less capable, but because efficiency matters more than performance. A creature that rushes risks starvation, one that waits endures. Even interactions between organisms reflect this change. Encounters are rare and often brief. When two creatures meet, they move carefully around one another, conserving energy and avoiding unnecessary contact. Aggression is minimized. Conflict is costly. Survival favors restraint. Over generations, this lifestyle becomes encoded into biology. Metabolism slow, hearts beat fewer times per minute. Cells operate at a gentler pace. Chemical reactions proceed steadily rather than rapidly. Life stretches outward in time, trading speed for longevity. This slow motion existence also changes how the environment is perceived. Without rapid movement, the ocean feels larger and quieter. Distances expand. A short journey may take hours or days. The absence of haste creates a different relationship with space, one defined by drifting rather than traveling. Patience becomes the defining trait of deep sea life. Waiting is not inactivity, it is strategy. A predator may remain nearly motionless for long periods, sensing subtle changes in water pressure or chemistry. A prey animal may drift silently, conserving energy while remaining alert. Stillness becomes a form of readiness. This patience replaces the surface world's reliance on speed. On land and in sunlit waters, quick reactions often mean survival. In the deep, they mean waste. The rules have shifted. Life succeeds by aligning itself with the slow delivery of resources and the constant presence of pressure and cold. As we continue our descent, the ocean feels increasingly unhurried. Movements blur into gentle arcs. Time stretches. Life unfolds without rush or noise. The deep does not demand urgency. It demands endurance. Here, slow motion is not an aesthetic choice. It is a necessity shaped by physics, chemistry, and scarcity. Energy arrives slowly, and so life responds slowly. In this quiet pacing, organisms find balance, existing comfortably within limits that would frustrate faster forms. The deeper we go, the more speed loses its meaning. What remains is a calm persistence, a way of living that values patience above all else. Life adapts not by moving faster, but by learning when not to move at all, letting time pass gently as the ocean carries everything forward in its own unbroken rhythm. At a certain depth, the last memory of the sun disappears, not gradually, not as a fading glow, but as a quiet certainty. Light no longer arrives here in any form that matters. What remains above has no influence below. This is the beginning of the midnight zone, a place of complete darkness all the time. There is no dawn here, no dusk, no gentle shift in brightness to suggest the passing of hours. The water is equally dark whether the surface world is bathed in midday sun or wrapped in night. For life in this zone, the sky might as well not exist. The concept of day and night loses meaning, replaced by a continuous present that stretches without interruption. Without light, time feels different. On the surface, life is guided by cycles. Light tells plants when to grow. Shadows tell animals when to move, when to hide, when to rest. In the midnight zone, these signals vanish. There is no daily rhythm to follow, no seasonal change to anticipate. Life becomes untethered from the patterns that shape most of Earth. Instead, behavior is guided by internal clocks that run slowly, or by the arrival of rare opportunities, a drifting scent, a passing vibration, a brief flash of living light. These moments do not arrive on schedule. They cannot be predicted. Life here learns to exist without expectation, responding only when something actually happens. The darkness itself is absolute. It does not soften with distance or shift with movement. It presses evenly in all directions, erasing orientation. Up and down lose their visual meaning. Without reference points, space becomes something felt rather than seen. Motion is sensed through pressure changes, through the movement of water across the body, through faint disturbances that ripple outward. In this environment, eyes offer little guidance unless paired with self-made light. Many creatures no longer rely on vision at all. Awareness spreads across the body, distributed rather than focused. The world is known through contact and proximity, through the slow reading of invisible cues carried by water. Life here does not rush. Without cycles to chase, there is no urgency. Activity unfolds according to need rather than time. Feeding, movement, and rest blur together, separated not by hours, but by availability. A creature may remain still for long periods, not sleeping in the surface sense, but conserving energy, waiting without impatience. Reproduction follows the same pattern. There is no season to mark the right moment. Instead, timing depends on encounters, on internal readiness, on conditions aligning by chance rather than calendar. This removes the pressure to synchronize with the environment. Life becomes self-contained, guided by internal states rather than external cues. The absence of surface rhythms also changes how long life unfolds. Without seasonal stress, without rapid shifts in temperature or light, the environment remains stable over long spans of time. This stability allows organisms to stretch their lives outward, aging slowly, changing gradually. Time becomes something experienced internally, not measured against a changing world. Even death takes on a different presence. In the midnight zone, remains do not decompose quickly. Cold temperatures and low activity slow every process. What falls here lingers, becoming part of the environment for extended periods. Nothing is rushed, not even decay. This constancy shapes the character of the midnight zone. It is not chaotic or violent. It is quiet, patient, and persistent. Life does not struggle against sudden change. It adapts to sameness, to an unbroken stretch of darkness that asks for endurance rather than flexibility. For creatures born here, darkness is not frightening or oppressive. It is simply the condition of existence. There is no memory of light to miss, no comparison to make. The body, the senses, and the behavior of these organisms are built around the assumption that nothing will ever be seen unless it creates its own glow. As we drift deeper into this zone, the ocean feels vast and still. The absence of light does not feel empty. It feels full, in a different way, filled with presence that does not announce itself. Life continues, quietly and steadily, detached from the surface world's cycles, unfolding according to rules shaped by darkness, pressure, and time. Here, Earth reveals one of its most unfamiliar faces, a world where life thrives without sunrise or sunset, where existence is continuous rather than cyclical, and where the deep ocean settles into its longest, darkest chapter, carrying on without reference to the light above. As darkness settles into permanence, another condition becomes impossible to ignore. Hunger is no longer an occasional challenge. It becomes a constant background presence, shaping every movement, every pause, every decision made in the deep. Food in this world arrives without warning. There are no plants growing nearby, no steady production of energy. What nourishment exists must travel from far above or emerge from rare chemical sources scattered across the seafloor. Most of the time, nothing arrives at all. The ocean here is vast, quiet, and sparsely supplied. Organic material drifts downward slowly, breaking apart as it falls. Much of it is consumed long before reaching these depths. What remains is thin and unevenly distributed. One area may receive a small pulse of nourishment, while another waits in emptiness for months or even years. There is no pattern to follow, no reliable schedule to anticipate. This unpredictability reshapes life in fundamental ways. In the deep, eating is not a daily activity, it is an event. When food appears, it must be used fully. When it disappears, the body must endure. To survive this rhythm, organisms evolve to stretch time between meals. Metabolism slow to a gentle pace, reducing the constant demand for fuel. Energy is conserved with care. Movements become sparse. Growth pauses when resources are low. Every internal process learns to wait. Many deep sea creatures develop the ability to store energy for long periods. Fatty tissues accumulate when food is available, acting as reserves during extended famine. Organs adjust their activity, operating at minimal levels until nourishment returns. The body becomes a vessel designed for patience. Digestive systems adapt as well. Meals, when they come, may be large compared to the size of the animal. Flexible stomachs expand to hold rare food, allowing the creature to take full advantage of opportunity. Digestion proceeds slowly, extracting as much value as possible from every fragment. Hunger also shapes behavior. Searching constantly for food would waste precious energy. Instead, many species adopt a waiting strategy. They remain still, suspended in the water or resting lightly on the seafloor, sensing the environment for signs of arrival. When something edible drifts close, action is taken. Until then, stillness is the most efficient choice. Predation becomes selective. Chasing prey over long distances is rarely worth the cost. Encounters are rare enough that most opportunities must be seized carefully. Mistakes carry high consequences. Missing a meal may mean waiting a long time for the next chance. This constant hunger encourages extreme efficiency. Bodies shed unnecessary features. Muscles slim. Organs reduce in size if they do not contribute directly to survival. Reproduction becomes infrequent and deliberate, timed to moments when energy reserves allow it. Nothing is wasted without reason. Even the brain adapts. Neural activity, which consumes significant energy, is streamlined. Responses become simpler, focused on essential tasks. Awareness remains sharp, but processing avoids excess. Life here values clarity over complexity. For surface creatures, hunger often signals emergency. In the deep, it is normal. Organisms are not starving in the dramatic sense. They are adapted to scarcity. Their biology assumes long intervals without food as part of the natural order. This does not make the deep ocean harsh or cruel. It makes it precise. Every trait that persists does so because it works under these conditions. Hunger becomes a shaping force, quietly guiding evolution toward forms that can endure absence without collapse. Over generations, this constant state of hunger becomes woven into the fabric of life. It defines pacing, behavior, and form. Creatures learn to exist comfortably within narrow limits, balancing intake and expenditure with remarkable accuracy. As we continue downward, the ocean feels increasingly sparse. Movement slows, encounters become rare, yet life persists, not despite hunger, but because of how well it has learned to live with it. Here, survival is not about abundance, it is about balance. Extreme efficiency replaces excess, patience replaces urgency. Hunger, ever present, becomes not an enemy, but a condition to be managed with quiet discipline. In this world, life proves that thriving does not require constant supply. It requires stability, restraint, and the ability to wait. And so the deep ocean carries on, populated by organisms that have mastered the art of enduring hunger, existing calmly within a realm where every meal is uncertain and every calorie truly matters. As hunger becomes a constant companion, bodies adjust in ways that may seem exaggerated at first glance. In the deep ocean, proportion follows opportunity rather than symmetry. Mouths widen, jaws stretch, stomachs soften and expand. These changes are not about aggression or dominance, they are about readiness. Speed, once useful near the surface, loses its advantage here. Chasing prey across long distances demands energy that cannot be easily replaced. In a world where meals are rare and unpredictable, fast pursuit becomes a gamble with poor odds. Missing a single opportunity may mean waiting a very long time for the next one. Over time, life favors a different strategy. Instead of moving quickly, it prepares to take advantage of whatever chance appears. Large mouths serve this purpose well. They increase the range of what can be eaten without requiring precision. A wide opening allows a creature to capture prey of varying sizes, shapes, and behaviors. It reduces the need for careful targeting. When something edible drifts close, the response can be simple and decisive. Open, engulf, hold. Elastic jaws and flexible tissues support this approach. Bones become lighter or partially detached. Ligaments stretch. Muscles relax into arrangements that allow wide movement without damage. The mouth becomes less a tool for tearing and more a doorway, designed to admit opportunity rather than refine it. Swallowing prey whole makes sense in this context. Chewing requires time and effort. Breaking food into smaller pieces delays digestion and increases exposure to loss. In the deep, efficiency matters more than elegance. Taking food in as it arrives preserves its value. Once inside, digestion can proceed slowly and completely, extracting energy over long periods. Elastic stomachs complement this strategy. They allow the body to accept meals much larger than what would normally be expected for its size. When food is rare, it is safer to over-prepare than to under-prepare. A stomach that can expand dramatically ensures that no opportunity is wasted. Even if the meal is larger than immediate needs, it can be stored and processed gradually. This ability reshapes the entire body plan. Organs shift position to accommodate expansion. Tissues stretch without tearing. Internal pressure balances carefully, maintaining function even as volume changes. These adjustments are not temporary tricks. They are built into the biology, refined over generations to work reliably under deep-sea conditions. The result is a set of proportions that feel unfamiliar. Heads appear oversized, mouths dominate faces, bodies seem built around feeding rather than movement. To human eyes, these forms can appear grotesque or exaggerated, but in the deep ocean, they are practical solutions. Big mouths also reduce the need for frequent feeding. By consuming larger meals when they appear, creatures can endure longer periods of scarcity, Energy intake becomes episodic rather than continuous. This fits naturally with the unpredictable nature of food supply in the deep. Sharp speed, by contrast, demands regular fuel. Fast muscles require constant maintenance. Rapid movement increases metabolic cost even at rest. In a world of scarcity, these traits become liabilities. Over time, they are replaced by designs that prioritize intake over pursuit. Exaggerated proportions also reflect the deep ocean's lack of visual signaling. There is little need for balanced appearance or streamlined elegance. What matters is function. If a larger mouth increases survival, it persists. If a smaller body reduces energy demands, it follows. Evolution trims and stretches without concern for how the result looks to an outside observer. This logic extends beyond feeding. Elasticity appears throughout the body. Skin stretches, tissues compress and rebound. These qualities support not only large meals, but also pressure changes, movement through dense water, and interaction with unpredictable environments. Flexibility becomes a universal advantage. As we drift alongside these forms, the ocean feels filled with quiet readiness. Creatures wait, not with tension, but with preparation. Their bodies hold potential rather than motion, designed to respond fully when opportunity arrives. In the deep, survival is not about constant action. It is about being prepared for rare moments that matter. Enlarged mouths and elastic stomachs embody this principle. They represent a shift from speed to capacity, from pursuit to acceptance. Here, exaggerated proportions are not excess, they are efficiency expressed visibly. Life stretches itself where it must, conserving energy where it can. And in doing so, the deep ocean reveals another way biology adapts to scarcity, shaping bodies that look unusual, but function with quiet precision in a world where every meal counts. As darkness settles into permanence and vision loosens its hold, the ocean does not become silent or empty. Instead, it fills with information that cannot be seen. In the deep, awareness shifts away from eyes and toward signals carried quietly through water itself. Scent and vibration take the lead, guiding life through a world defined not by images, but by presence. Water is an exceptional messenger. Unlike air, it holds on to molecules, suspending them for long periods and allowing them to drift slowly across great distances. A trace released in one place does not vanish quickly. It spreads, thins, and lingers, forming invisible paths that can be followed with patience and precision. In this environment, smell becomes more than a sense, it becomes a map. Chemical signals reveal what has passed through the water before. A drifting trail may speak of food broken apart above, of another body moving nearby, of danger recently present. These signals do not announce themselves sharply, they unfold gradually, growing stronger or weaker depending on distance and time. Life learns to read these gradients, interpreting faint changes the way surface animals read sound or sight. Many deep-sea creatures possess finely tuned receptors that sample the water constantly. Their bodies test the environment without movement, gathering information while remaining still. A slight change in chemical balance may prompt slow adjustment in direction, a gentle turn, a cautious drift. Decisions are made quietly, without urgency, guided by cues that never appear all at once. Vibration works alongside scent, filling in gaps where chemistry alone is not enough. Water carries motion efficiently. A small movement sends ripples outward, subtle waves of pressure that travel farther than sound in air. These vibrations reveal size, distance, and direction. They announce approach or retreat, They sketch outlines of bodies without ever forming an image. To sense these movements, deep sea life develops sensitivity across the skin and along specialized structures. Fine hairs bend with passing currents. Internal canals register pressure shifts. The body becomes an instrument, listening to the ocean through touch rather than sound. This awareness does not require speed or force. It depends on stillness and attention. Together, scent and vibration create a layered understanding of the environment. Chemistry reveals what has been. Pressure reveals what is happening now. Combined, they allow life to respond without ever needing to see. A predator may detect prey long before contact, adjusting position slowly, conserving energy. A prey animal may sense disturbance and choose stillness, blending into the surrounding water. This way of knowing reshapes behavior. Movement becomes deliberate because movement creates signals. Stillness becomes informative because it allows the environment to speak first. Life learns to wait for information rather than seeking it actively. Awareness becomes distributed across the body, not focused in a single organ. Communication also adapts to this invisible language. Chemical cues can signal readiness, identity, or territory. These messages persist, allowing others to encounter them later, long after the sender has moved on. Vibration patterns, produced intentionally or incidentally, convey presence without exposure. Together, they form a quiet network of interaction, layered and subtle. To human perception, this world feels empty because it lacks visible markers, but to its inhabitants, it is rich with detail. Every current carries history. Every disturbance leaves a trace. The ocean is constantly speaking, even when it appears still. This reliance on invisible information also reduces reliance on constant energy expenditure. Sensing scent and vibration requires far less energy than maintaining large eyes or processing complex images. It fits naturally into the deep ocean's economy of restraint. Awareness remains high while costs remain low. As we drift deeper, the idea of perception itself begins to change. Knowing no longer means seeing. It means detecting, interpreting, and responding to signals that arrive slowly and quietly. Life becomes attuned to absence as much as presence, to what is missing as much as what is there. In this environment, sight does not vanish because it fails. It steps aside because better tools are available. Smell and vibration offer reliability where light cannot. They provide continuity in a world without cycles, without reference points, without surface rhythms. Here, life is guided by information that never appears as form or color. Paths are traced without lines. Encounters unfold without images. The deep ocean becomes a place navigated through intuition built from chemistry and motion, where existence depends on listening to what cannot be seen and trusting signals that drift softly through the dark, carrying meaning without ever revealing themselves to the eye. As life continues its quiet adjustment to depth, another transformation becomes clear. Strength, as it is known at the surface, slowly loses its value. Heavy muscles and rigid frames, once useful for lifting bodies against gravity and driving fast movement, begin to feel unnecessary. In the deep ocean, they become a burden. Muscle is costly tissue. Even at rest, it consumes energy. It demands oxygen, nutrients, and constant maintenance. On land and in shallow water, this cost is balanced by benefit. Muscles allow rapid escape, powerful hunting, and precise movement through complex environments. But in the deep, where food is scarce and motion is slow, that balance shifts. Large muscles offer little advantage when there is no ground to push against and no need to sprint. Gravity still exists, but it is softened by buoyancy. Water supports the body from all sides, reducing the need for constant muscular effort. A creature does not have to hold itself upright. It does not have to fight its own weight. In this environment, muscle mass becomes excess. Over time, bodies respond by letting go, muscles thin, fibers shorten, strength is replaced with endurance and control. Instead of powerful contractions, movement relies on gentle pulses and subtle adjustments. Energy once spent on maintaining bulk is redirected toward survival, toward sensing the environment, toward patience. Skeletons follow the same path. Dense bones are heavy and expensive to build. They require minerals that are not easily replaced in the deep. They also increase body weight, making buoyancy harder to manage. As a result, many deep sea creatures reduce their skeletal structure. Bones become lighter, porous, or partially replaced by cartilage. In some cases, rigid skeletons are minimized to the point where they offer shape rather than support. This reduction has a powerful effect on buoyancy. When a body's density closely matches that of the surrounding water, it can hover effortlessly. No constant swimming is required to stay afloat. No energy is wasted resisting, sinking, or rising. The creature becomes suspended, free to remain in place with minimal effort. Neutral buoyancy changes how life moves through the ocean. Instead of traveling by force, bodies drift. Small adjustments in fin angle or body position allow gentle movement in any direction. The water itself becomes a partner, carrying the organism rather than resisting it. This style of motion suits a world where speed is unnecessary and efficiency is everything. Reduced muscles also support the deep ocean's quiet nature. Large, powerful movements create vibrations that travel far. In a place where detection can mean danger or wasted energy, subtlety matters. Smaller muscles produce less disturbance. Movement becomes quieter, less noticeable, and easier to control. This softness can make deep-sea bodies appear fragile. Limbs look thin, frames seem incomplete. Compared to surface animals, these creatures can look underbuilt. But this impression comes from judging them by the wrong standard. They are not designed to lift, run, or wrestle with gravity. They are designed to exist within water, not against it. The trade-off is clear. Reduced structure limits what these bodies can endure outside their environment. Brought to the surface, many cannot support themselves. Without pressure and buoyancy, tissues collapse. This fragility is not a flaw. It is evidence of specialization. These bodies are optimized for one world only. Within that world, the design is elegant, energy use drops dramatically, survival time increases, the body becomes a balanced system, spending little and wasting less. Muscles work only when needed. Skeletons provide just enough structure to hold form, no more. This optimization also allows life to persist in a stable way over long periods. With fewer resources devoted to growth and power, organisms can afford to live slowly. Repair happens gradually. Aging stretches across long spans of time. The body remains in balance with its environment, neither overbuilt nor underprepared. As we drift alongside these hovering forms, the ocean feels weightless. Life seems suspended in place, unhurried and calm. There is no struggle against gravity here, no constant effort to remain upright or mobile. Bodies exist in quiet agreement with the water around them. In the deep ocean, strength is not measured by force, it is measured by fit. Fragile skeletons and reduced muscles reflect a simple truth. When gravity loosens its grip and energy becomes precious. Survival belongs to bodies that learn how to float, not fight, allowing the ocean to hold them as they move gently through its dark, patient depths. As the deep ocean stretches outward in darkness and distance, one of life's most basic needs becomes one of its greatest challenges. Reproduction, so often guided by proximity, timing, and abundance in the surface world, must adapt to an environment where encounters are rare and isolation is the norm. In the deep, space is vast and sparsely occupied. Bodies drift through enormous volumes of water, often separated by long distances. There are no gathering places shaped by light or landscape, no seasons that draw life together at predictable moments. A creature may live its entire life without ever crossing paths with another of its kind. Finding a mate in such conditions becomes an unlikely event rather than an expectation. Movement is slow, energy is limited. Searching actively would require more fuel than most bodies can afford to spend. As a result, reproduction cannot rely on chance encounters alone. Evolution responds with strategies that reduce dependence on meeting another individual at the right moment. Some species adopt extreme specialization. One partner becomes mobile and searching, while the other remains relatively stationary. When contact finally occurs, the connection may become permanent. In these cases, reproduction is secured not through repeated encounters, but through long-lasting union. Once joined, separation never occurs, ensuring that future opportunities are not lost. Other organisms take a different path. They become both male and female, carrying the ability to produce and receive reproductive cells within the same body. This flexibility increases the chance that any encounter, no matter how rare, can result in reproduction. Identity becomes adaptable, shaped by circumstance rather than fixed roles. Chemical communication plays a crucial role in this process. Signals released into the water drift slowly, extending the reach of an individual far beyond its physical body. These chemical traces announce readiness, guiding potential partners across distance. Though faint, they persist, allowing connection even when movement is minimal. Timing also adapts. Without seasons or light cycles to coordinate behavior, reproduction becomes opportunistic. Instead of waiting for a specific period, organisms remain prepared for long stretches of time. When conditions align, when energy reserves allow, when another body finally arrives, reproduction can proceed without delay. In some species, eggs and sperm are released freely into the water, trusting currents to carry them together. This method sacrifices certainty for reach. Most reproductive cells will never meet, but a few will, and in a world defined by patience, that is enough. Life accepts loss as part of the process. Loneliness shapes these strategies quietly but deeply. Isolation does not produce urgency or desperation, it produces efficiency. Traits that increase the probability of success, even slightly, are favored over time. Anything that reduces dependence on frequent contact becomes valuable. This leads to bodies and behaviors that appear unusual when compared to surface life. Some creatures remain reproductively ready for years. Others store genetic material from past encounters, using it long after the meeting itself has ended. In this way, time becomes flexible. Reproduction is no longer tied closely to the moment of contact. The emotional weight humans associate with loneliness does not apply here. For deep sea life, isolation is not absence. It is the default state. Biology adapts accordingly, removing expectations that cannot be met. The drive to reproduce remains strong, but it is expressed through strategies that fit the environment rather than resisting it. Energy constraints further refine these adaptations. Producing offspring is costly. In the deep, reproduction often occurs infrequently, with fewer young produced each time. But those offspring are often well developed, equipped to survive in harsh conditions from the beginning. Quality replaces quantity, reflecting the high cost of existence in the deep. Parental investment may extend beyond physical protection. Chemical defenses, energy rich yolks, or early developmental advantages help ensure survival without ongoing care. Once released into the environment, young must be capable of enduring long periods alone, just as their parents do. As we drift through this quiet world, reproduction feels less like a moment and more like a long strategy unfolding across time. It is shaped by distance, scarcity, and stillness. Life does not rush to multiply. It waits, prepares, and adapts. In the deep ocean, isolation does not end the story of reproduction, it rewrites it. Evolution responds not with abundance, but with ingenuity. Connection becomes rare, precious, and carefully preserved. And in this darkness, life continues, sustained by strategies that honor the reality of loneliness while ensuring that the lineage, slow and steady, carries on. As life settles into darkness, scarcity, and stillness, time itself begins to behave differently. In the deep ocean, days do not pass in any meaningful way. There is no sunrise to mark a beginning, no sunset to signal an end. Without cycles to divide experience, time loosens and stretches, becoming something felt internally rather than measured externally. This change reshapes how long life lasts. Many deep sea creatures live far longer than their surface relatives, not because they are protected from danger entirely, but because the pace of existence slows to a gentle crawl. When energy is scarce and movement is minimal, the body learns to spend carefully. Every process eases back, including aging itself. Metabolism lies at the heart of this transformation. On the surface, warm temperatures and abundant food drive rapid chemical activity. Cells divide quickly, tissues repair and wear down at a faster pace. Life burns bright and fast. In the deep ocean, cold water and limited energy slow these reactions. Cells work patiently. Chemical exchanges take longer to complete. Nothing is rushed. This slower metabolism reduces damage over time. Fewer chemical reactions mean fewer errors, fewer byproducts that stress cells, fewer moments where systems are pushed to their limits. Wear accumulates slowly. Repair has time to keep pace. The body remains stable for long stretches, changing gradually rather than constantly. Growth follows the same pattern. Many deep-sea organisms grow slowly, adding small increments over long periods. A body may take years to reach maturity, but once it does, it often remains in that state for decades. There is little pressure to grow quickly when resources are scarce and competition is subtle. Reproduction, too, contributes to longevity. Infrequent breeding reduces strain on the body. Energy is not repeatedly diverted toward producing offspring. Instead, long intervals between reproductive events allow organisms to recover fully, maintaining balance rather than cycling through exhaustion. The deep ocean also offers a kind of environmental consistency that supports long life. Temperatures remain stable, light does not fluctuate, seasonal extremes never arrive. Without sudden changes, bodies do not need to constantly adapt. Stress remains low and predictable. Stability becomes a quiet ally of longevity. Predation patterns reinforce this effect. While danger exists, encounters are rare. The vastness of the environment spreads life thinly. Many creatures may go long periods without crossing paths with predators or competitors. Survival depends less on constant vigilance and more on steady endurance. Over time, evolution favors traits that support long life rather than rapid turnover. Slow metabolism, efficient repair mechanisms, and conservative energy use become defining features. Life does not hurry toward reproduction and decline. It unfolds gradually, each stage given time to settle. This leads to lives measured not in short bursts, but in decades. Some deep sea animals may live longer than any land mammal, their bodies quietly persisting in darkness while generations pass above. Their experience of time is not compressed by urgency, it is expansive, open, and patient. To human minds shaped by clocks and calendars, this stretch of time feels almost unreal. We measure life by milestones, by years counted and counted again. In the deep, time is less about counting and more about continuity. One moment flows gently into the next without sharp division. A creature may drift for hours without moving. Days may pass without noticeable change. Years slip by, marked only by slow growth or gradual wear. Life does not rush toward an ending. It simply continues, supported by conditions that favor persistence over speed. As we drift alongside these long-lived forms, the ocean feels ancient in a new way, not just old in age, but old in rhythm. Everything moves slowly, steadily, without impatience. Time does not press forward. It expands outward. In the deep ocean, longevity is not a luxury. It is a consequence of living gently within limits. Slower metabolism leads to slower aging. Stability leads to endurance. Life learns that survival does not require haste, only balance. Here, existence stretches across decades, sometimes longer, carried forward by bodies that change so slowly they seem almost timeless. And in this quiet extension of life, the deep ocean reveals one of its most subtle truths. When energy is scarce and the world remains still, time itself becomes generous, allowing life to persist, calmly and patiently, far beyond the pace we know at the surface. As the descent continues, the ocean floor finally opens into something vast and unexpected. The terrain does not rise into mountains or break into forests of stone. Instead, it stretches outward in quiet simplicity. This is the abyssal plain, an immense, flat expanse that covers more of Earth than any other single habitat. The seafloor here rolls gently, almost imperceptibly, shaped by sediments that have been falling for millions of years. Fine particles drift down from the surface world, settling grain by grain into a soft, endless carpet. There are no landmarks to guide the eye, no dramatic features to interrupt the horizon. The plain extends in every direction, calm and uninterrupted, a landscape defined by absence rather than form. Life exists here, but it is spread thin. Vast distances separate one living body from the next. A creature may drift or crawl for long stretches without encountering anything at all. The ocean feels immense and empty, not because life is absent, but because it is so widely spaced. This is a world where isolation is not occasional, but constant. Food arrives rarely on the abyssal plain. What little nourishment reaches this depth has already traveled far, stripped of much of its energy along the way. Organic material settles slowly onto the seafloor, scattered unevenly. One patch may receive a small deposit, while another remains untouched for long periods. There is no predictability, only patience. Survival here demands restraint. Movement is minimized because wandering wastes energy without guarantee of reward. Many creatures adopt a slow, deliberate existence, conserving strength and responding only when necessary. Stillness becomes a strategy, not a sign of absence. Life waits rather than searches. Bodies adapt to this sparse environment in subtle ways. Shapes remain low and close to the ground, reducing energy spent maintaining position. Some organisms spread wide across the sediment, increasing their chance of intercepting falling material. Others remain compact, ready to endure long stretches without food. Each form reflects a careful balance between opportunity and cost. The abyssal plane also favors longevity. With few disturbances and little competition, life unfolds slowly. Growth takes time, change happens gradually. The environment remains stable over long spans, allowing organisms to persist without constant adjustment. In this stillness, endurance becomes the defining trait. Encounters, when they happen, carry weight. A passing scent, a faint vibration, a shadow against the dark floor can signal opportunity or danger. There is little room for error. Energy spent unwisely may not be recovered for a long time. Decisions are cautious, measured, shaped by the knowledge that the next chance may be far away. Despite its emptiness, the abyssal plane is not lifeless. It supports a quiet network of organisms linked by slow processes and minimal exchange. Bacteria work unseen within the sediment, breaking down what little organic matter arrives. Larger creatures depend on these subtle transformations, forming a food web that operates at the edge of viability. This is survival refined to its bare essentials. There is no abundance to buffer mistakes, no rapid reproduction to compensate for loss. Life persists here because it has learned to exist with almost nothing, to stretch resources across time and distance with remarkable discipline. To human perception, the abyssal plane can feel desolate, even barren. But this impression comes from expecting density, motion, and variety. In reality, the plane represents a different expression of life's capacity. It shows that biology does not require constant activity or crowded spaces to endure. It can survive in quiet balance, spread thin across enormous scales. As we drift above this flat, shadowed world, the ocean feels larger than ever. The plane extends beyond sight, beyond imagination, covering much of the planet beneath miles of water. It is Earth's largest continuous habitat, yet one of its most understated. Here, life exists at the edge of possibility. It does not thrive in abundance or speed. It survives through patience, efficiency, and resilience. Every organism on the abyssal plane represents a successful answer to scarcity, a living proof that even in the most minimal conditions, life finds a way to continue. In this vast stillness, the deep ocean reveals another quiet truth. Life does not always need richness or complexity to persist. Sometimes it needs only stability, time, and the discipline to endure. The abyssal plane holds that lesson gently, spread across its endless floor, carrying on without spectacle, yet covering more of Earth than almost any place we know. As we drift farther into the deep, form itself begins to loosen. The outlines that once defined animals in familiar ways no longer hold. Heads, tails, backs, and bellies still exist, but their relationships change. Symmetry, once a guiding principle of life near the surface, slowly breaks down. In brighter worlds, symmetry offers advantage. Balanced bodies move efficiently. Left and right mirror one another, distributing force and simplifying control. On land and in shallow water, symmetry supports speed, stability, and coordination. But in the deep, those benefits fade. Motion is slow, gravity is softened, Speed no longer decides survival. As these pressures fall away, symmetry loses its purpose. Without the need for fast directional movement, bodies are free to change. They stretch or compress depending on what best suits survival. Some organisms become long and ribbon like, their bodies extended to increase surface area or improve sensory reach. Others flatten against the seafloor, spreading themselves thin to conserve energy and remain unnoticed. Still others twist into shapes that feel irregular, as though molded by the water rather than designed by rules. These forms are not mistakes, they are responses to an environment where efficiency replaces elegance. When food arrives rarely and unpredictably, a longer body may intercept more particles drifting past. A flattened shape may rest closer to the sediment, conserving energy while remaining alert. Distortion becomes utility. Symmetry also assumes a clear sense of direction. Front moves forward, back follows. In the deep ocean, orientation becomes less important. There is no visible horizon. Up and down are felt, not seen. Movement happens slowly, often in place rather than across distance. In this context, having a clearly defined front and back matters less. Bodies adapt accordingly. Some creatures distribute sensory organs unevenly, placing them where they are most useful rather than evenly across both sides. Others allow internal organs to shift position, accommodating expansion, pressure, or feeding without concern for balanced appearance. What matters is function, not form. As these changes accumulate, familiar outlines begin to lose meaning. A body may still be alive and active, yet no longer resemble what the human mind categorizes as an animal. The shape may appear abstract, more like drifting material than a living being. Movement may be so subtle that it seems absent altogether. This unfamiliarity comes from our expectations, not from disorder. We are accustomed to animals shaped by gravity, light, and speed. The deep ocean removes those shaping forces and replaces them with others. Pressure, scarcity, and stillness guide evolution instead. The resulting forms reflect those priorities clearly, even if they feel strange to us. Elongation, flattening, and distortion also help manage energy. Long bodies can house extended digestive systems, allowing slow extraction of nutrients. Flat bodies reduce vertical profile, minimizing movement and exposure. Irregular shapes break up outlines, reducing detection by predators that sense presence through vibration or faint light. In many cases, the idea of a single, solid body gives way to something more fluid. Appendages may trail loosely, tissues may ripple gently with the water, boundaries soften. The difference between organism and environment becomes harder to define. Life blends into the surrounding darkness, existing as part of the ocean rather than apart from it. These forms challenge the notion that evolution moves toward complexity or refinement in a visual sense. In the deep, evolution moves toward suitability. If a shape works, it remains. If it does not, it fades away. There is no preference for beauty, balance, or familiarity. Over time, this process produces bodies that feel almost symbolic rather than anatomical. They represent solutions to specific problems rather than members of a recognizable group. The concept of animal becomes flexible, stretched to include forms that drift, spread, or hover without clear edges. As we continue through this region, the ocean feels increasingly abstract. Life is present everywhere, yet rarely announces itself through shape. Recognition gives way to uncertainty. Familiar outlines dissolve into suggestion. In this place, shape no longer serves to reassure or identify. It serves only to survive. And so, the deep ocean teaches another quiet lesson. Animals do not have to look like animals as we imagine them. They only have to exist in a way that fits their world. Here, form follows function so completely that appearance becomes secondary. Symmetry fades, distortion becomes normal, and life continues, shaped not by what we recognize, but by what endures in the still, dark patience of the deep. As the deep ocean continues to strip away familiar supports, even food begins to lose its central role. In some places, life no longer waits for fragments to fall from above. It draws energy from the earth itself, tapping into processes far older and quieter than sunlight. Along cracks in the seafloor, the planet releases its breath. Warm fluids seep upward, carrying dissolved chemicals forged deep within rock. These flows do not glow or roar. They rise slowly, spreading into the cold water like invisible smoke. Where they appear, the logic of survival shifts completely. Here, certain forms of life no longer depend on eating other organisms. Instead, they rely on chemistry. Specialized microbes use the energy stored in substances such as methane and sulfur, transforming chemical imbalance into living matter. These reactions do not require light. They do not require falling debris. They depend only on contact between water and the restless interior of the planet. This process unfolds quietly at the smallest scales. Microscopic organisms cluster where chemical flows emerge, building communities molecule by molecule. They form the foundation of ecosystems that look nothing like the food chains of the surface world. There are no plants, there is no photosynthesis. Energy moves upward from rock and fluid rather than downward from the sun. Methane plays a central role in some of these systems. Trapped within sediments or released from deep reservoirs, it carries energy formed long before it reached the ocean. Certain microbes can break it apart, harvesting its stored potential and converting it into usable forms. In doing so, they create the base upon which larger organisms depend. Sulfur follows a similar path. Compounds rich in sulfur seep from the seafloor, often toxic to surface life. But in the deep, these substances become fuel. Microbes transform them through slow chemical exchanges, building living tissue from what would otherwise be poison. Life here does not avoid harsh chemistry. It embraces it. Around these microbial foundations, entire communities gather. Larger organisms form partnerships with the microbes, housing them within their own bodies. The microbes provide energy. The host provides protection and access to chemical flows. This cooperation blurs the line between individual and environment, turning survival into a shared process. The logic behind this way of living is fundamentally different. There is no waiting for food to arrive, no dependence on distant ecosystems. As long as chemical energy continues to flow, life can persist in place. Stability replaces unpredictability. The environment becomes a steady provider rather than a source of rare opportunity. This changes how bodies are shaped and how behavior unfolds. Movement becomes minimal because there is no need to search. Feeding becomes internal, handled by symbiotic processes rather than hunting or filtering. Growth aligns with the pace of chemical supply rather than the arrival of meals. These ecosystems often appear clustered and localized, standing out against the emptiness of the surrounding abyssal plain. Where chemistry rises from below, life gathers. Where it does not, the sea floor remains sparsely inhabited. The deep becomes a patchwork of scarcity and quiet abundance, determined not by light or falling debris, but by geology. To human understanding, This form of survival feels almost alien. We associate life with consumption, with eating, and being eaten. Chemical survival bypasses that logic entirely. Energy does not pass from body to body through predation. It flows from Earth into life directly, guided by reactions rather than encounters. Yet this way of living is neither new nor rare in Earth's history. It may resemble some of the earliest forms of life, born before sunlight shaped ecosystems. In the deep ocean, this ancient strategy persists, protected from surface change by distance and depth. As we drift past these quiet communities, the ocean feels less dependent on the world above. Life here does not wait for permission from the sun. It continues as long as the planet itself remains active, releasing energy through cracks and seams. Chemical survival reveals a deeper truth about life's flexibility. Food, as we understand it, is only one path. Light is only one source. Biology can reorganize itself around entirely different rules, building ecosystems from chemistry alone. In these dark, steady places, life follows a logic shaped by rock, fluid, and time. It moves slowly, persists patiently, and exists independently of the rhythms that govern the surface world. And in doing so, the deep ocean reminds us that life does not depend on comfort or familiarity. It depends on opportunity, even when that opportunity comes not from above, but from the quiet chemistry rising from within the earth itself. As the ocean deepens further, pressure no longer feels like a challenge to be endured. It becomes something else entirely: a boundary, a shield, a quiet form of protection that reshapes who can enter and who must remain above. For life adapted to the surface, pressure is unforgiving. Bodies built for air and shallow water rely on internal spaces, rigid structures, and delicate balances that collapse under compression. Lungs, gas-filled cavities, dense bones, and tightly folded proteins all become points of failure. Even strong predators from the upper ocean, fast and powerful in their own realm, would struggle to function here for more than moments. Pressure does not attack violently. It presses evenly and constantly, leaving no direction of escape. For organisms not built to withstand it, systems fail quickly, circulation falters, cells lose integrity, movement becomes impossible. Strength offers no defense against a force that acts everywhere at once. For deep sea life, this same pressure becomes familiar. Their bodies are shaped around it, their chemistry tuned to function while compressed. What threatens outsiders supports insiders. And so depth becomes more than a place to live. It becomes a barrier. This barrier is not visible, but it is absolute. Few surface predators can cross it. Those that do briefly cannot hunt effectively. Their speed means nothing. Their senses fail. Their bodies struggle to maintain form. Even if they descend accidentally, they are forced to retreat quickly or perish. As a result, many deep-sea species live beyond the reach of threats that dominate shallower waters. Sharks, large fish, and marine mammals rarely venture into these depths. The energy cost is too high. The physiological risk too great. Pressure quietly filters the ocean, separating worlds without walls. This separation reshapes behavior. Deep-sea creatures do not need to invest heavily in defenses designed to repel fast, powerful attackers. Thick armor, speed bursts, and aggressive displays lose importance. Instead, survival depends on compatibility with the environment itself. Pressure does the guarding. Depth also limits competition. Species that might dominate elsewhere cannot enter. Niches remain stable. Food webs become simpler and slower, not because life is weak, but because few outsiders can interfere. Extremity creates safety. This does not mean danger disappears. Predation still exists, but it follows different rules. Encounters are rare, movements are slow. Threats come from organisms equally adapted to pressure, not from overwhelming invaders. Risk becomes measured rather than constant. For some species, descending deeper offers refuge. Juveniles may settle at greater depths to avoid surface predators. Others spend most of their lives below, rising only briefly if at all. Depth becomes a place of relative calm, not because it is gentle, but because it is selective. Pressure as protection also influences body design. Without the need to resist crushing jaws or high-speed pursuit, bodies can remain soft, flexible, and efficient. Energy once spent on defense is redirected toward endurance, sensing, and patience. The environment itself provides the boundary. Over time, this creates communities that feel isolated but stable. The deep ocean becomes a series of guarded layers, each one protected by the difficulty of entry. Depth is not simply a habitat stacked beneath another. It is a filter that allows only certain forms of life to pass. To human imagination, extreme environments often feel dangerous, but in the deep ocean, extremity offers predictability. Pressure does not fluctuate, it does not surprise. It remains constant, shaping life steadily rather than violently. For those adapted to it, this consistency becomes a form of safety. As we drift deeper, the sense of intrusion fades. The surface world feels distant and irrelevant. Life here unfolds without fear of sudden invasion. The ocean closes in not as a threat, but as a guardian, holding its inhabitants within conditions few others can tolerate. This is safety through extremity, a world so demanding that only the prepared may enter, a place where survival depends not on dominance, but on belonging. In the deep, pressure becomes a quiet ally. It protects not by force, but by exclusion. And in doing so, it allows life to persist calmly, shielded from the chaos above, living within a realm defined not by openness, but by depth itself. As the deep ocean shapes life with precision, it also sets firm limits. The same adaptations that allow survival under crushing pressure become liabilities when that pressure is removed. For many deep-sea creatures, the journey upward is not a return, it is a breaking point. Pressure in the deep is not an occasional condition. It is the environment itself, present in every cell and tissue. Bodies grow accustomed to being supported from all sides, balanced perfectly against the weight of the water above. This constant compression becomes part of how organs hold their shape and how fluids remain where they belong. When a deep-dwelling organism is brought toward the surface, that balance unravels. Pressure drops rapidly. The surrounding support vanishes. Tissues that were stable under compression begin to expand uncontrollably. Gases dissolved within fluids come out of solution. Spaces form where none existed before. Cells suffer first. Membranes stretch beyond their limits. Structures that functioned smoothly while compressed lose alignment. Proteins that folded correctly under pressure begin to misbehave, disrupting the chemistry that keeps cells alive. What once worked effortlessly now strains against unfamiliar conditions. Organs follow, soft tissues swell, delicate internal arrangements shift and tear, blood vessels rupture. The body is no longer held together by its environment. Instead, it must support itself, a task it was never designed to perform. Even skeletal structures, already reduced and flexible, offer little help. Without the surrounding pressure, bodies collapse under their own weight. Shapes distort, movement becomes impossible. What looks fragile to surface eyes is revealed to be specialized beyond recovery. This is why many deep sea creatures die shortly after being brought up, even when handled with care. It is not shock in the emotional sense, it is physics. The environment that sustained them has been removed, and their biology cannot compensate quickly enough. The damage is often irreversible. Returning an organism to depth does not restore what was lost. Once tissues have expanded, ruptured, or shifted, the precise balance required for function cannot be easily reestablished. The deep is not forgiving of interruption. This fragility highlights how completely these bodies belong to their world. They are not versatile travelers, they are specialists, tuned so precisely to one set of conditions that even small changes carry enormous consequences. Their survival depends on constancy, not adaptability across extremes. From the surface perspective, this limitation can feel tragic. A creature that thrives in one of Earth's largest habitats cannot survive a brief visit to the realm above. But this view misunderstands the nature of specialization. Deep sea life is not incomplete. It is complete within its own context. Bodies built for the deep trade flexibility, for efficiency, they give up the ability to tolerate change in exchange for perfect alignment with a stable environment. This trade-off allows life to persist where few others could. It is the price of belonging fully to a single world. The cost of returning to the surface also reinforces the separation between ocean layers. Depth is not just distance, it is difference. Worlds stack atop one another, each governed by conditions that cannot be easily crossed. The deep remains protected not only by pressure, but by incompatibility. For humans, this reality offers a humbling reminder. Exploration comes with limits. Observation can disturb what it seeks to understand. The deep ocean is not a place that can be sampled freely without consequence. Its inhabitants are not built for exchange. As we imagine drifting back upward, the contrast becomes clear. The surface world is dynamic, variable, and forgiving of change. The deep is steady, precise, and exacting. Life there depends on balance maintained without interruption. Bodies built for one world only tell a quiet story of commitment. They reflect an evolution that chose depth fully, abandoning the ability to move between realms. In doing so, they gained access to safety, stability, and time at the cost of fragility outside their home. The deep ocean does not ask its life to travel, it asks it to stay. And so, the cost of returning to the surface is not failure. It is evidence of how completely life has adapted to the dark, pressurized calm below, becoming inseparable from the world that shaped it. As we take in the deep ocean's strange forms, a familiar word often rises uninvited: alien. It feels natural, almost automatic. Yet this reaction does not come from the creatures themselves. It comes from us, from the way the human mind has learned to understand life. Our brains are built for pattern recognition. From early moments, we learn the shapes and movements that signal safety, threat, or familiarity. We recognize animals by symmetry, by faces that face forward, by limbs that move with purpose. These patterns evolved in bright, shallow environments where speed, balance, and clear outlines mattered. Over time, they became shortcuts, efficient ways to decide what something is and how to respond to it. In the deep ocean, those shortcuts stop working. Bodies here do not follow the rules our brains expect. Symmetry loosens, faces fade, limbs stretch, thin, or disappear. Movement slows or becomes nearly imperceptible. Transparency replaces color. Light comes from within rather than above. The mind reaches for familiar categories and finds none that fit cleanly. When pattern recognition fails, discomfort appears. Not fear exactly, but uncertainty. The brain struggles to decide whether what it sees is animal, object, or environment. Without clear cues, it hesitates. That hesitation often feels like strangeness. This response is deeply rooted in evolution. For most of human history, unfamiliar shapes in the dark could mean danger. Mistaking a predator for something harmless carried high cost. The brain learned to treat ambiguity with caution. Better to feel unsettled than to ignore a possible threat. In the deep ocean, that ancient system activates without context. The shapes are unfamiliar, the movements unexpected, the cues incomplete. The brain does what it has always done. It flags the unknown as different, and difference becomes alien. Yet nothing about these creatures is unnatural. They are shaped by consistent rules, just not the ones we know best. Our expectations are tuned to gravity that pulls downward, to light that reveals edges, to environments where speed and strength dominate. The deep replaces those forces with pressure, darkness, and scarcity. Evolution follows suit. When we call deep sea life alien, we are not identifying something foreign to Earth. We are encountering the limits of our own perspective. The discomfort does not come from the biology itself, but from the mismatch between our mental models and the environment that shaped these forms. Even familiar features take on unfamiliar roles. Eyes grow large or vanish, mouths expand beyond proportion, bodies soften or elongate until they resemble drifting fabric more than muscle and bone. These changes challenge the brain's ability to label and categorize. Our pattern recognition systems prefer efficiency. They rely on repetition. When shapes repeat, recognition becomes easy. In the deep, repetition exists, but at a different scale and rhythm. Encounters are rare, variation is subtle, forms blend into their surroundings. The brain cannot gather enough examples quickly enough to build comfort. This is why the deep feels unsettling rather than frightening. The reaction is quieter, a sense of wrongness without clear reason. The mind knows it is seeing life, but it cannot place it. The result is a feeling of distance, of otherness. The word alien becomes a placeholder for uncertainty. Over time, with exposure and understanding, that reaction can soften. When we learn the rules that govern the deep, shapes begin to make sense. Soft bodies reflect pressure. Large mouths reflect scarcity. Slow movement reflects energy limits. The unfamiliar becomes logical once the context is understood. This shift reveals something important about human perception. Our sense of what is natural is not universal, it is local. It reflects the conditions under which our minds evolved. When those conditions change, our intuition lags behind reality. Deep sea life does not violate nature, it expands it. It shows how flexible biology can be when shaped by different constraints. The discomfort we feel is not a warning, it is an invitation to recognize that life does not owe us familiarity. As we drift alongside these forms, the label alien begins to lose its power. What once felt strange becomes coherent. What once resisted recognition begins to tell a story of adaptation and balance. In this realization, the deep ocean offers a gentle lesson. Strangeness often reveals more about the observer than the observed. When our expectations fail, it is not because the world is wrong, but because it is larger than the patterns we carry. And in that quiet understanding, the deep stops feeling alien. It becomes simply another expression of life, honest in its differences, shaped by rules we are only beginning to learn how to see. As we move deeper into the logic of the deep ocean, one idea quietly falls away. There is no design here in the way humans usually imagine it, no intention toward beauty, no final form being perfected. What exists instead is a long chain of trade offs, each one shaped by necessity rather than preference. In the surface world, appearance often seems purposeful. Bright colors signal health, symmetry suggests balance, graceful movement implies strength. These traits can matter when environments are visible, competitive, and crowded. But in the deep, those signals lose their meaning. Light does not reveal color, movement is slow, encounters are rare, there is no audience. As a result, nothing here is optimized for how it looks. Forms are not shaped to be admired, recognized, or even easily understood. They are shaped to function under pressure, darkness, and scarcity. If a trait works, it remains. If it does not, it fades away. There is no reward for elegance. Every feature carried by a deep-sea organism represents a compromise. A large mouth allows rare meals to be captured, but it may reduce mobility. Soft tissues handle pressure well, but offer little protection outside the deep. Reduced muscles save energy, but limit strength. Transparent bodies avoid detection, but sacrifice visual identity. Each gain comes paired with loss. These compromises are not carefully planned. They emerge gradually through countless small changes, each one favoring survival by the smallest margin. Over time, the accumulation of these choices produces bodies that appear unusual to us, not because they are poorly designed, but because they are precisely adapted to conditions we do not share. In the deep, there is no single best solution. There is only what works well enough. Evolution does not aim for perfection. It aims for persistence. Traits are not refined endlessly. They are retained until conditions change or a better alternative appears. This is why deep sea life often looks unfinished or mismatched to human eyes. Parts seem oversized or reduced. Shapes feel asymmetrical or distorted. The mind looks for harmony and finds imbalance. But the imbalance reflects honest compromise. A body optimized for one challenge must accept weakness in another. Beauty, as humans define it, requires context. It depends on light, proportion, and familiarity. Remove those elements, and beauty loses relevance. The deep ocean replaces them with pressure, chemistry, and time. In that setting, survival becomes the only meaningful measure. This does not mean life here is careless or chaotic. On the contrary, it is precise. Every trait persists because it contributes something essential. Nothing is wasted without reason. If a structure remains, it is because removing it would cost more than keeping it. If something looks excessive, it is because scarcity demands readiness. The absence of design also means there is no final form. Deep-sea species continue to change slowly, adjusting to shifts in chemistry, food supply, and pressure over immense spans of time. What we see today is not an endpoint. It is a snapshot of balance achieved under current conditions. This understanding reshapes how we interpret strangeness. What appears alien is not deviation from a plan. It is the visible record of trade-offs made under extreme constraints. When appearance feels unsettling, it is often because we are seeing compromise laid bare, without decoration or familiarity to soften it. Survival replaces appearance entirely. Traits are judged not by how they look, but by how little they cost and how much they allow. Does this body move without wasting energy? Does it endure long hunger? Does it function under pressure? Does it avoid detection? These are the only questions that matter. In the deep ocean, evolution becomes honest. It strips away anything unnecessary and keeps what works, even if the result defies expectation. There is no attempt to please. No need to conform to recognizable shapes. Life exists for itself alone. As we drift among these forms, the idea of design gives way to appreciation for constraint. Every creature carries the story of its environment written directly into its body. No decoration, no excess, just balance. And in that balance, the deep ocean offers a quiet reminder. Nature does not build toward beauty, it builds toward survival. Beauty is something we notice after the fact, when our expectations happen to align with function. In the deep, those expectations fall away, leaving us face to face with life as it truly is, shaped not by intention, but by the long, patient negotiation between possibility and cost. As the deep ocean strips life down to its essentials, another assumption quietly dissolves. Evolution is often imagined as a journey with a destination, a slow climb toward improvement, complexity, or perfection. But in the depths, that idea has no footing. There is no upward path here, no final shape waiting to be reached. There is only adjustment, happening again and again, without direction or intent. Evolution does not move toward an ideal. It responds to conditions. When those conditions change, life changes with them. When they remain stable, life settles into balance. The deep ocean makes this especially clear because its environment is so consistent and so extreme. Pressure, darkness, cold, and scarcity do not fluctuate wildly. They persist, and life responds not by advancing, but by fitting itself as precisely as possible into what already exists. There is no goal written into this process, no blueprint guiding bodies toward a particular form. A trait appears because it helps, even slightly, under specific circumstances. If it stops helping, it fades. If it helps again later, it may return in a different way. Nothing is permanent. Nothing is planned. In the deep, this lack of direction becomes visible. Forms do not become more elegant or more complex over time. They become more appropriate. Soft tissues replace rigid ones. Speed gives way to patience. Vision fades or transforms. These changes do not represent progress in a human sense. They represent alignment. Depth acts as an extreme filter in this process. Only certain strategies can pass through. Bodies built for brightness and abundance cannot function here. Traits suited to the surface fail quickly under pressure and darkness. What remains is not better life, but compatible life. This filtering does not reward innovation for its own sake. A new trait must offer immediate benefit or it will not persist. There is no room for excess experimentation when energy is limited. Changes happen slowly, cautiously, guided by small advantages that accumulate over long spans of time. Because of this, evolution in the deep often appears conservative. Once a workable solution emerges, it remains largely unchanged. Not because evolution has stopped, but because the environment does not demand further adjustment. Stability produces continuity. When conditions do shift, perhaps through changes in chemistry, food supply, or geology, evolution responds again, not by moving forward, but by moving sideways. Traits are repurposed, structures shift function, bodies reorganize to meet new constraints. There is no return to previous forms, only ongoing response. This is why similar shapes can appear in unrelated lineages. Long bodies, soft tissues, enlarged mouths, reduced skeletons emerge again and again. Not because evolution is repeating itself intentionally, but because the environment keeps presenting the same problems. When conditions are similar, solutions converge. Depth sharpens this effect. Its constraints are so strong that they narrow the range of viable outcomes. Life does not explore endlessly. It circles around a limited set of possibilities, refining them quietly over time. From a human perspective, this can feel disappointing. We expect change to mean advancement. We look for direction. But the deep ocean teaches a different lesson. Change is not about becoming something better, it is about staying possible. Evolution has no memory of where it has been and no knowledge of where it might go. It reacts to the present moment. Every generation inherits what worked before and adjusts slightly based on what works now. That is all. In this sense, evolution resembles the deep ocean itself. It moves without haste. It follows no map. It responds to pressure and flow rather than destination. It shapes life not toward an end state, but toward continued existence. As we drift through these depths, the absence of direction becomes calming rather than unsettling. There is no race, no finish line. Life unfolds at its own pace, shaped by conditions rather than ambition. The deep ocean reveals this truth clearly because it strips away illusions of progress. What remains is a process that is patient, responsive, and ongoing. Evolution does not ask where life should go next. It asks only one question, again and again. Does this work here? If the answer is yes, life continues. If not, it changes. And so the deep carries on, filled with forms that are not moving toward anything in particular, yet remain perfectly matched to where they are. A reminder that survival does not require direction, only the quiet ability to adjust, endure, and remain possible within the world as it is. As the story widens, scale begins to matter more than detail. When we step back from individual forms and behaviors, the deep ocean reveals itself not as a fringe environment, but as the main stage. It is Earth's largest habitable space, stretching across most of the planet, occupying volumes far greater than all land combined. The surface world feels dominant because it is where humans live. Forests, grasslands, deserts, and cities fill our awareness. Light defines our sense of space. Air shapes our movement. But these environments occupy only a thin skin around the planet. Beneath them lies a vast interior world of water, deep and continuous, where life has persisted for far longer than it has on land. In terms of sheer volume, the deep ocean dwarfs everything else. Most of Earth's living space exists below the reach of sunlight, under pressure, in cold and darkness. These conditions are not rare exceptions, they are the norm. The surface, by comparison, is a narrow band of relative warmth and brightness, a brief transition between atmosphere and abyss. Life began in water, and for most of Earth's history, it never left. Even after some lineages adapted to land, the majority of living matter remained in the ocean. Depth offered stability when the surface changed. Ice ages came and went. Continents shifted. Atmospheres transformed. The deep endured with fewer disruptions, allowing life to continue quietly while the world above reshaped itself. This long continuity explains why the deep ocean hosts such a wide range of strategies. Life here had time to experiment, adjust, and settle into forms that work under constant conditions. While surface ecosystems respond quickly to seasonal cycles and rapid change, the deep evolves slowly, guided by patience rather than urgency. Surface life, for all its diversity, is constrained by variability. Temperature shifts daily and seasonally. Weather alters landscapes. Light cycles dictate behavior. These forces demand flexibility and speed. They reward rapid growth, quick reproduction, and constant movement. In contrast, the deep rewards endurance, efficiency, and restraint. Seen this way, surface life is the exception. It exists in a dynamic, narrow zone where conditions fluctuate constantly. The deep ocean represents the more common state of Earth's environment: cold, dark, pressurized, and stable. Life that thrives there reflects what biology looks like when change is slow and limits are firm. Humans sit far outside this pattern. Our bodies are built for air, warmth, and light. We rely on oxygen-rich atmospheres and narrow temperature ranges. We require constant energy input and frequent rest. Without technology, we cannot survive even brief exposure to deep ocean conditions. This makes humans an anomaly in Earth's broader biological story. We inhabit one of the smallest and most unstable portions of the planet. We experience the world through senses tuned to light and sound in air, not pressure and chemistry in water. Our intuition about life reflects that narrow experience. When we encounter deep sea organisms, the mismatch becomes clear. Their forms do not align with our expectations because our expectations are shaped by an environment that represents only a fraction of Earth's living space. The deep does not look strange because it is rare. It looks strange because it is unfamiliar to us. In truth, humans are the unusual ones. We live on the edge of the planet's habitable volume, adapted to a thin layer that supports rapid change and visual complexity. Our sense of normal is shaped by exception. Recognizing this shifts perspective. The deep ocean is not an afterthought. It is the foundation. It holds most of Earth's water, most of its living space, and much of its biological history. Life there does not exist in spite of harsh conditions. It exists because those conditions are stable and predictable. As we drift through this understanding, the planet feels different. Earth becomes less a world of land dotted by oceans, and more an ocean world with scattered islands of air and light. The deep becomes the rule, not the deviation. In this context, the alien feeling fades. What remains is humility. Life is far more flexible than human experience suggests. It thrives across conditions we cannot endure, filling spaces we rarely see. Earth's largest habitable space lies beneath us, quiet and immense, carrying on without reference to surface rhythms. And within it, life continues in forms shaped not by our needs or perceptions, but by the long, steady reality of a planet that is mostly deep, dark, and alive. After traveling through darkness, pressure, scarcity, and time, the deep ocean offers something quieter than revelation. It offers clarity, not about specific creatures or extreme adaptations, but about life itself and what it truly requires to continue. The deep shows that biology is far more flexible than surface experience suggests. Life does not cling to a single form, temperature, or rhythm. It does not insist on light, warmth, or abundance. Given enough time, it reshapes itself around almost any set of rules. Muscles thin, bones soften, senses change direction, energy flows along unfamiliar paths. Yet life persists, recognizable not by appearance, but by continuity. This flexibility does not come from strength, it comes from adjustment. Deep sea life does not overpower its environment, it yields to it. Pressure is not resisted, it is accepted. Darkness is not fought, it is incorporated. Scarcity is not avoided, it becomes the framework within which every process operates. From the surface, we often associate life with comfort, warmth, air, regular meals, clear cycles of day and night. These conditions feel necessary because they are familiar. But the deep reveals that comfort is optional, stability is not. The deep ocean is harsh by human standards, but it is remarkably steady. Temperatures change little, pressure remains constant, darkness never lifts. In this consistency, life finds something more valuable than ease. It finds predictability. When conditions are stable, biology can tune itself precisely, refining small efficiencies over long spans of time. This is why the deep supports such enduring forms of life, not because it is gentle, but because it is reliable. Change happens slowly. Disruption is rare. Life has the space to adjust without being repeatedly undone. Time plays a central role in this process. Many deep adaptations would be impossible over short spans. They require generations of small changes, each one offering only slight advantage. In a stable environment, those advantages accumulate over millions of years. Bodies transform in ways that would seem extreme if they happened quickly, but feel natural when stretched across deep time. The deep ocean reminds us that life does not rush. It waits. It experiments quietly. It accepts limits rather than trying to escape them. Where energy is scarce, life becomes efficient. Where movement is costly, life becomes still. Where encounters are rare, life becomes patient. This patience reshapes our understanding of survival. We often imagine life as something that thrives through competition, speed, and dominance. The deep offers a different model: survival through restraint, through cooperation with the environment rather than struggle against it, through fitting into narrow margins rather than expanding endlessly. Biology here does not seek maximum growth, it seeks balance. It does not aim to conquer space, it occupies it lightly. This approach allows life to persist where excess would fail. The deep also reveals that intelligence, complexity, and beauty are not prerequisites for endurance. Many deep organisms are simple in structure, slow in behavior, and subtle in presence. Yet they persist across ages, outlasting countless surface lineages that burned brightly and vanished. In this way, the deep ocean acts as a mirror, reflecting assumptions back at us. It shows that our measures of success are shaped by our environment. Speed feels important because we live in a fast world. Visibility feels essential because we live in light. Comfort feels necessary because our bodies demand it. Life itself does not share those preferences. What it needs is opportunity, consistency, and time. Give biology a stable set of conditions and enough generations, and it will find a way to inhabit them. Not always gracefully, not always visibly, but effectively. As we drift through this realization, the deep ocean feels less like a place of extremes and more like a teacher. It does not shout its lessons, it repeats them quietly, across miles of water and millions of years. Life does not need comfort, it does not need familiarity, it does not need our approval. It needs only a world that remains long enough for adjustment to take hold. The deep provides that world, and in doing so, it reminds us that life on Earth is not fragile in the way we often imagine. It is resilient through flexibility, enduring through patience, and sustained not by ideal conditions, but by the quiet power of stability and time working together, far below the surface, where existence continues without needing to be seen. As our journey settles into stillness, the deep ocean lingers in the mind, not as a place of spectacle, but as a presence. Layer upon layer, it has carried us away from familiarity, not abruptly, but gradually, until the shapes of life no longer mirror our own. The farther we traveled, the less recognizable everything became. This distance was never a rejection, it was a revelation. The deep does not reshape life to oppose us, it reshapes life to match itself. Pressure, darkness, scarcity, and time leave no room for pretense. Every trait that remains has earned its place. Nothing is decorative. Nothing exists for comfort or appearance. What survives does so honestly, carrying only what works. From our perspective, this honesty can feel unsettling. We are used to reading the world through reflections of ourselves: faces, eyes, symmetry, motion that echoes our own movements. When those cues disappear, we feel displaced. But that discomfort does not come from danger, it comes from difference. The deep ocean reminds us that resemblance is not a requirement for life. Familiarity is not a universal standard. Biology does not revolve around us, even though our senses often suggest it does. Life expands outward in many directions at once, shaped by environments we rarely experience and cannot endure. In the darkness below, life does not apologize for its forms. It does not explain itself. It simply exists, balanced carefully within limits we are only beginning to understand. That existence is not lesser for being unfamiliar. If anything, it is more precise, stripped of excess, refined by necessity. What we have seen is not a parade of oddities, but a continuum. Each change followed naturally from the last. Light faded, food thinned, pressure increased, time slowed. With each shift, life adjusted. The result was not chaos, but coherence under new rules. This progression carries a quiet message. Life is not fragile because it breaks easily. It is resilient because it bends. It does not insist on ideal conditions. It works with what remains. In the deep, there is no promise of comfort, yet life persists. There is no abundance, yet ecosystems endure. There is no light, yet awareness continues through other means. Stability, not ease, becomes the foundation. For humans, this perspective can feel humbling. Our world of air and light occupies a thin edge of the planet's possibilities. We thrive in a narrow range of conditions, protected by technology and habit. Without them, we are vulnerable. The deep reveals that most of Earth operates beyond those limits, quietly and continuously. And yet, this does not place us outside the story. We are not separate from the deep, even if we cannot enter it freely. Its processes shape the planet we live on. Its currents influence climate. Its chemistry affects the air we breathe. Its life forms share ancestry with ours, connected across immense spans of time. We belong to the same Earth, even if we occupy different layers of it. The deep ocean is a reminder that our experience is not the measure of reality. It shows us worlds that do not center human needs, senses, or expectations. In doing so, it invites a gentler understanding of our place, not as observers standing above nature, but as participants within a much larger system. The farther life moves from us in form, the more clearly it reflects the planet's capacity for variation. It is not wrong because it does not resemble us. It is honest because it resembles its environment exactly. As we let this journey come to rest, the deep does not demand awe or fear. It offers perspective. It asks us to recognize that Earth holds many worlds at once, some welcoming, some unreachable, all interconnected. There are places we were never meant to enter, not because they reject us, but because they do not need us. Their existence does not depend on being seen or understood. And yet, they remain part of the same living planet that shaped us. In that understanding, the deep ocean becomes less alien and more familiar in a different way. not as a mirror, but as a reminder. Life is vast, possibility is wide, and our own form is only one quiet variation within a much larger, patient story unfolding far below the surface, whether we are there to witness it or not.